Hi there, you're in the lab with your mate JJ. Today is Old Book Teardown Day. Today we're going to be tearing down an old book. So the job title for today is Tone Pumper. Today I'm the Tone Pumper. And the tone we'll be pumping is this old guy, the Encyclopedia of Electronic Circuits. This is volume 1. There are 7 volumes. We'll be looking at all of them, starting with this one, volume 1, today. This book was published in 1985. This is the 4th printing. I'm not sure how many printings there were. Yeah, there'll be links in the show note to the book if you want to have a look further. What we're going to do is we're going to pop over to the bench together and have a look at what's inside this book. We'll flip through the table of contents, and then I think we'll just skim through the book and look at all the circuits that are in there. Basically, as it says, it's an encyclopedia of electronic circuits. So basically, there's all these example circuits, and they're categorized into various sections to sort of organize them so you can hopefully find what you're looking for. It's probably going to be a long video. We'll find out soon how long it is, but yeah, we're going to go through this this monster. It's going to take quite a while. It must be thick paper because there's only 760 pages. Usually a book that thick's more like 1,000, so that's good. It's only 760 pages. Makes it a bit easier to get through. So let's pop over to the bench together and see what's in this book. Here on the bench, this is our book. So on the front there, I don't know what 1938 means. Why is that there? I don't know. The Encyclopedia of Electronic Circuits, Rudolf F. Graf. It's funny, later he teams up with someone called Sheets, so it's Graf and Sheets, which is kind of amusing. We've got little circuit diagrams on the front here, just pictorial. The Encyclopedia of Electronic Circuits, Rudolf Graf, the most comprehensive, up-to-date, and easy-to-use collection of electronic circuit designs available today. Printed by Tab Books, Blue Ridge Summit, PA. Is that Pasadena? I'm not sure. Send for free tab catalog describing over 750 current titles in print. There you go. All right, well, I'm just going to go grab my coffee. I'll be back. All right, I've got my coffee. Very important. It's going to be a long haul. So let's open up this bad boy and see what we're dealing with. Wow, this was $60. Number 1938. $60. $60 was a lot of money in 1985. To Alison Nicole, a joy to behold. Disclaimer. All of the corporations represented in this book make no warranty, express or implied, that information on the products contained herein is applicable. Specifications and availability of products herein described are subject to change without notice. There you go. All right, and then we've got the table of contents. Goes on for 3 pages. Okay, so what's in this book? Acknowledgements, introduction, common schematic symbols, alarms, amateur radio, amplifiers, analog to digital converters, attenuators, audio mixers, audio oscillators, audio power amplifiers, audio signal amplifiers, automotive, battery chargers, battery monitors, buffers, capacitance, touch operated circuits. Okay. Carrier current circuits, comparators, converters, crossover networks, crystal oscillators, current measuring circuits, current sources and sinks, DC-DC and DC-AC converters, decoders, delay circuits, detectors, digital to analog converters, dip meters, displays, dividers, drivers, fiber optic circuits, field strength meters, filters, flashes and blinkers, frequency measuring circuits, frequency multipliers, frequency to voltage converters, fuzz circuits, games, gas vapor detectors, indicators, infrared circuits, instrumentation amplifiers, light activated circuits, light controls, light measuring circuits, liquid level detectors, logic circuits, measuring circuits, metal detectors, metronomes, miscellaneous circuits, mixers and multiplexers, modulation monitors, modulators, moisture and rain detectors, motor controls, multivibrators, noise generators, oscilloscope circuits, phase sequence and phase shift circuits, photography related circuits, power measuring circuits, power supplies fixed, power supplies variable, power supply protection circuits, probes, pulse generators, radiation detectors, ramp generators, receivers, resistance and continuity measuring circuits, RF amplifiers, RF oscillators, remote control circuits, safety and security circuits, sample and hold circuits, Schmidt triggers, smoke and flame detectors, sound effect circuits, sound audio operated circuits, Squarewave oscillators, stereo balance circuits, switches, telephone related circuits, temperature controls, temperature sensors, timers, tone control circuits, transmitters, ultrasonic circuits, video amplifiers, voltage and current sources and reference circuits, voltage controlled oscillators, voltage to frequency converters, voltmeters, waveform and function generators, zero crossing detectors, sources, and index. Acknowledgements. Bunch of companies acknowledged there. Introduction. This volume of timely and practical circuits highlights the creative work of many people. Featured here are many circuits that appeared only briefly in some of our finer periodicals or limited circulation publications. Also included are other useful and unique circuits from more readily available sources. The source for each circuit is given in the sources section at the back of the book. The bold figure number that appears inside the box of each circuit is the key to the source. For example, the high stability voltage reference circuit shown below is figure 93-10. If you turn to the sources section and look for figure 9310, you will find that Precision Monolithics supplied this circuit from page 6 to 142 of their full line catalog. This is figure 93.9. Okay, figure 93.10, Precision Monolithics Incorporated, 1981, full line catalog, P6 142. Not sure what that really means. Many circuits are accompanied by a brief explanatory text. Those that do not have text can be readily understood from similar circuits in that chapter, or else they may be too complex to be explained briefly. The sparseness of text is deliberate so as to allow for more circuits, which, after all, is what this book is all about. The index and contents will be a time saver for the reader who knows exactly what he is looking for. The first page of each chapter lists the circuits in the order that they appear. Okay. The browser will surely discover many ideas and circuits that may well turn out to be most rewarding and great fun to put together. The common schematic symbols chart will help you identify circuit components. This is the common schematic symbols chart. All right, what have we got? No connection, connection, male, female, board connectors, phone plug, phone jack, okay, phono plug, phono jack, not sure what that is, AC socket, banana jack, shielded cable, AC plug, voltage or signal source, ground, 2 voltage source or signal, voltage or signal in. Alright, we've got fuse, crystal, microphone, speaker, antenna, meter, headphones, neon lamp, incandescent lamp, diode, Zener, pin diode, LED, photodiode, varactor, SCR, so triac, constant current source, transistors, PNP, NPN, N-channel and P-channel junction FET, N-channel and P-channel uni-junction, N-channel enhancement mode MOSFET, P-channel enhancement MOSFET, N-channel enhancement / depletion MOSFET, P-channel enhancement / depletion MOSFET. Alright. Photo transistor, inductor air core, inductor iron core, inductor adjustable. Alright. Transformer, relay, resistor, potentiometer, potentiometer trimmer. Okay. Capacitor, electrolytic capacitor, non-polarized capacitor. Okay, that's interesting. Capacitor variable, capacitor trimmer. Okay. Battery single cell, battery multi-cell, thermistor, varistor, light dependent resistor. It's single pole, single throw switch, SPDT switch, slide switch, rotary switch, push button switch, amplifier or a buffer, inverting amplifier or buffer, AND gate, NAND gate, OR gate, NOR gate, exclusive OR gate, and IC package. Okay, so there we go. Some there that you don't see very often, like the neon lamp or the incandescent lamp, even headphones. Although I suppose I saw headphones today. What was I looking at? Oh yeah, it was a YouTube video about crystal radios. Anyway, here we are, Chapter 1, Alarms. The sources of the following circuits are contained in the sources section. Alright, so let's, what have we got? Are we going to read it out, or are we just going to go through? Yeah, we'll read it out. Compute alarm. Automotive burglar alarm, security alarm, vehicle security system, home security monitor system, anti-theft device, auto burglar alarm, tamper-proof burglar alarm, latching burglar alarm, motion activated motorcycle or car alarm, boat alarm, blown fuse alarm, auto burglar alarm, continuous tone, 2 kHz buzzer with bridge drive gated on by a logic 0, pulse tone alarm, gated by high input with direct drive output, piezoelectric alarm, gated 2 kHz buzzer, burglar alarm, latching burglar alarm, sun-powered alarm. All right. So there's our compute alarm. This circuit has a built-in self-arming feature. The driver turns off the ignition, presses the arm button on the compute alarm, and leaves the car. Within 20 seconds, the alarm arms itself, all automatically. The circuit will then detect the opening of any monitored door, the trunk lid, or the hood on the car. Once activated, the circuit remains dormant for 10 seconds. When the 10-second time delay has run out, the circuit will close the car's horn relay and sound the horn in periodic blasts, approximately 1-2 seconds apart, for a period of 1 minute. Then the compute alarm automatically shuts off to save your battery and rearms. If a door, the trunk lid, or the hood remains ajar, the alarm circuit re-triggers and another period of horn blasts occurs. The compute alarm has a key switch by which the driver can disarm the alarm circuit within a 10-second period after he enters the door. The key switch consists of a closed circuit jack J1 and a mating miniature plug. There we go. Well, we won't look at all of the circuits in the same level of detail, but there you go. So just to be clear, well, just with regard to car alarms, I think that they were like a relic of the 80s and the 90s where people thought they were a good idea. But they usually just set themselves off, didn't they? They hardly ever caught someone stealing a car, and they used to just create a nuisance all the time. So you don't see many car alarms these days, do you? Anyway, okay, we've got a little Darlington transistor in there. A couple of relays are used in this circuit. A couple of Zener diodes. Interesting. Bipolar junction. Silicon-controlled rectifier. Yeah, there you go. A couple of switches to the door. All right, this is the automotive burglar alarm, which is using a 555 timer, or two 555 timers. It's probably to create the tone. The alarm triggers on after a 13-second delay and stays on for 1 to 1.5 minutes. Then it resets automatically. It can also be turned off and reset by opening and reclosing S1. Here is S1. Yeah. There it connects up. All right. Oh wow, this is a monster. Look at this. Security alarm. All right, there's a lot of integrated circuits in there. Circuit notes. This alarm features open and closed loop detector and automatic alarm shutoff. Offers 15-second exit entrance delay. Alarm on time can be adjusted from 1 to 15 minutes. There you go. It uses a 5.5 timer as well. And it looks like they've got an integrated circuit or two full of NAND gates. That looks like NAND gates to me. Yeah, there we go. IC123, CD4011, quad 2 input NAND gates. So there you go. All right. This is the vehicle security system. This is using NOR gates. This alarm gives it, so that it's just another security alarm. Bunch of switches. Home security monitor system. It's got some digital logic in there. Anti-theft device. Any momentary break in the protective loop or tripping of the normally closed vibration sensor causes the alarm to sound for 20 seconds. If the circuit is open all the time, the alarm will sound continuously. Auto burglar alarm. Dome light current through L1 closes read switch and sounds alarm. Shaker switch also activates alarm. Yeah, right. It's a pretty basic circuit. So, tamper-proof burglar alarm. If R2 is open or shorted, the alarm sounds. Yeah, right. Latching burglar alarm. When the protective circuit is interrupted, open, the alarm sounds. To set the circuit, adjust R2 with protective circuit open for 1 volt across R1. Pretty simple circuit. Motion activated motorcycle or car alarm. Boat alarm. Blown fuse alarm. Okay, so it's got 1 meg resistors and a couple of bipolar junction transistors. If the fuse blows, the LE indicator starts to blink. Ah, there you go. Interesting. Auto burglar alarm uses the 556. I'm not sure what the 556 is. Is it like a 555? I'm not sure. Continuous tone, 2 kilohertz buzzer with bridge drive gated on by a logic 0. Okay. and pulsed tone alarm, gated by a high input with direct drive output. You've got piezoelectric alarm, a burglar alarm, gated 2 kHz buzzer, latching burglar alarm, sun-powered alarm, freezer meltdown alarm, amateur radio, code practice oscillator produces automatic dits and dars, RF power meter, inline watt meter, CW signal processor, 2 meter preamplifier for handy talkies, repeater beeper, electronic keyer, code practice oscillator, automatic tape recording, self-powered CW monitor, remote RF current readout, code practice oscillator, SWR warning indicator, sub-audible tone encoder, audio mixers, RF powered side tone oscillator, harmonic generator, automatic TTL Morse code keyer, remote RF current readout. This is the code practice oscillator, produces automatic dits and dars. The circuit consists of a basic oscillator and an automatic keyer below the dashed line. There's the dashed line. The unit can be used with a straight hand key or a paddle key for automatic operation. RF power meter, okay. Inline watt meter. Oh, yeah, that's interesting. CW signal processor. So what does CW stand for? Is it continuous wave? I forget what it is. Something to do with radio signals. 2 meter preamplifier for handy talkies. Repeater beeper. It's using the 556 again. Electronic keyer. I'm going to go and find out what the 556 is. I'll be back. All right. So a 556 is 255s in the same package. So it's just basically 2 555 timers. Good to know. Might as well look up CW as well, huh? Yes, CW is continuous wave, and it's used for Morse code, and it's either on or it's off, and it just sends a tone. All right. 2 meter preamplifier for handy talkies. We call those usually walkie-talkies, wouldn't we? Repeater beeper. Okay, it's another 555 jobby. Electronic keyer. Code practice oscillator. Okay. Automatic tape recording. Gee, that's a blast from the past. Self-powered CW monitor. Remote RF current readout. Code practice oscillator. SWR warning indicator. Sub-audible tone encoder. Audio mixer. Yeah, right. Just a bunch of inputs. Capacitor, volume control, and 741 amplifier. There you go. The 741 op-amp is used as a summing amplifier to combine several audio inputs. Overall gain is set by RF. There's RF up there. F for feedback, maybe. RF powered side tone oscillator, harmonic generator, automatic TTL Morse code keyer. Got some logic in there. That looks like a, is that a bridge rectifier? I'm not sure. Automatically generate dits and dars are produced over a speed range of 11 to 39 words per minute. The upper limit can be raised. Right. I'm not quite sure what that does. Amplifiers. We've got a long list of amplifiers. All right. High impedance differential amplifier, unity gain follower, voltage controlled variable gain amplifier, power booster, logarithmic amplifier, voltage controlled variable gain
amplifier, discrete current booster, precision process control interface, voltage controlled amplifier, programmable gain non-inverting amplifier with selectable inputs, times 1000 amplifier circuit, inverting amplifier with balancing circuit, switching power amplifier, precision power booster, non-inverting voltage follower, color video amplifier, fast voltage follower, isolation amplifier for capacitive loads, cable bootstrapping, current booster, wideband unity gain inverting amplifier with a 75 ohm system, or in a 75 ohm system, high-speed current to voltage output amplifier, gated amplifier, reference voltage amplifier, fast summing amplifier, adjustment-free precision summing amplifier with low input current, times 10 operational amplifier using L161, times 100 operational amplifier using L161, precision absolute value circuit, ultra-low leakage preamp, DC to video log amplifier, plus or minus 100 volt common mode range differential amplifier, wide bandwidth low noise low drift amplifier, signal distribution amplifier, audio distribution amplifier, high input impedance, high output current voltage follower, precision amplifier, pre-amplifier and high to low impedance converter, non-inverting amplifier, high impedance, high gain, high frequency inverting amp, log ratio amplifier, inverting amplifier. Wow, that's a lot of amplifiers. This high impedance differential amplifier uses the MU A798 what is it? Amplifier. It's an IC. A unity gain follower uses the NE5517. Voltage controlled variable gain amplifier implemented with a couple of FETs. Power booster, the 5535, some sort of amplifier. Logarithmic amplifier using the LM11C. Okay. Voltage controlled variable gain amplifier, the LM101. Discrete current booster, LM387A. Couple of bipolar junction transistors and resistors. Alright, precision process control interface, the LH0044 and the LH0070. It hasn't copied real well, it's a bit blurry. Voltage controlled amplifier. This circuit is basically an op-amp with an extra input at pin 5. A current IABC is injected into this input and this controls the gain of the device linearly. There's two ICs there, but it's not clear what those are. Absolute value amplifier. This circuit generates a positive output voltage for either polarity of input. Okay, cool. Programmable gain non-inverting amplifier with selectable inputs. 1000 times amplifier circuit. Okay. It's two different types of amplifier chip used there. Inverting amplifier with balancing circuit. Okay. Precision power booster. Switching power amplifier. Non-inverting voltage follower. Color video amplifier. Isolation amplifier for capacitive loads. Fast voltage follower. Bandwidth, power bandwidth 15 kilohertz. Slew rate 1 volt per microsecond. Cable bootstrapping. Bootstrapping input shield for a follower reduces cable capacitance, leakage, and spurious voltages from cable flexing. Instability can be avoided with small capacitor on input. Current booster. High-speed current to voltage output amplifier. Wideband unity gain inverting amplifier in a 75 ohm system. Logarithmic amplifier. Gated amplifier. Fast summing amplifier. 250 kilohertz. Reference voltage amplifier. Adjustment-free precision summing amplifier. Summing amplifier with low input current. Times 100 operational amplifier using L161. Operational amplifier using, it's a times 10 operational amplifier using L161. Amplifier is a 3 decibel down at 100 kilohertz and has a slew rate of 0.02 volts per microsecond. Precision absolute value circuit. Ultra low leakage preamp. Input leakage 2 picoamps at 75 degrees Celsius. Plus or minus 100 volt common mode range differential amplifier. DC to video log amplifier. Wide bandwidth, low noise, low drift amplifier. Signal distribution amplifier. Audio distribution amplifier. High input impedance, high output current voltage follower. Precision amplifier. Preamplifier and high to low impedance converter. Non-inverting amplifier. High impedance, high gain, high frequency inverting amp. Log ratio amplifier. Inverting amplifier using the LM377. Chapter 4, Analog to Digital Converters. 8-bit analog to digital converter. Successive approximation AD converter. 8-bit AD converter. 8-bit tracking AD converter. 8-bit successive approximation AD converter. 4-channel digitally multiplexed ramp AD converter. 3-decade logarithmic AD converter. Tracking servo type AD converter. 3.5-digit AD converter with LCD display. Fast precision AD converter. High speed 3-bit AD converter. 3 IC low cost AD converter. All right. Wow, these are complex, aren't they? So this is our first 8-bit. This is our first 8-bit analog to digital converter, and there's a parallel output there. Cool. A couple of a couple of integrated circuits there. The 9650s. Not sure what those are. Quad 2 divider. All right. This is the successive approximation AD converter. Wow. A bipolar input high-speed analog to digital converter uses two AM25LO3s to form a 14-bit successive approximation register. The comparator is a two-stage circuit with an HA2605 front-end amplifier used to reduce settling time problems at the summing node. Careful offset nulling of this amplifier is needed. Alright, and here's an 8-bit converter using a ZN425E and an amplifier there, the ZN42AP, and a bunch of logic. 8-bit tracking AD converter, 8-bit successive approximation AD converter, 4-channel digitally multiplex ramp AD converter, 3-decade logarithmic AD converter, tracking servo type AD converter. I'm not sure what that means. Is it talking about servos like actual little motor thingies? I don't know. 3.5 digit AD converter with LCD display. Oh, fascinating. So, okay. It's mostly done with a Teledyne 8750 CMOS, 3.5 digit. So this is basically an integrated circuit that does this. Fast precision AD converter. All of these are really implemented with integrated circuits, aren't they? High speed 3-bit analog digital converter. Oh wow. Typical conversion speed 30 nanoseconds. Input voltage range 3.5 volts. 3 IC low cost AD converter. Okay, so it uses 3 integrated circuits and it's cheap. Great. It looks like it's got output 8 bits. Attenuators. Digitally selectable precision attenuator, variable attenuator, digitally controlled amplifier / attenuator, programmable attenuator 1 to 0.0001. All right. Digitally selectable precision attenuator, variable attenuator. The PN4391 provides a low RDS on less than 30 ohms. The T attenuator provides for optimum dynamic linear range for attenuation, and if complete turnoff is desired, attenuation of greater than 100 decibels can be obtained at 10 MHz, providing proper RF construction techniques are employed. Digitally controlled amplifier / attenuator. I think we saw that DAC 1020 earlier, didn't we? I'm not sure. Programmable attenuator. Okay, using an integrated circuit to do the heavy lifting. Audio mixers. 4-input stereo mixer, high-level 4-channel mixer, 2-channel panning circuit, CMOS mixer, mixer preamplifier with tone control, passive mixer, 1-transistor audio mixer, silent audio switching / mixing, hybrid mixer, and 4-channel mixer. This is the 4-input stereo mixer. Okay. 4 or more inputs can be mixed and produce stereo output. Gain of each stage can be boosted by adding RX, but it should be kept below 50, RX above 2.2K, to avoid poor frequency response. If more than 4 stages are used, decrease RX to 6.8K for 6 inputs or 4.7K for 8 inputs. The op-amps are 741 or other lower noise types. The power supply circuit is also given. Great. High-level 4-channel mixer. The integrated circuit is the RCA CA3052. To provide good signal-to-noise ratio, this 4-channel mixer amplifier controls the signal levels after the amplifiers and then mixes them to offer a combined output. The circuit works with any 50 ohm to 50 kilo ohm dynamic microphone, 50K dynamic microphone, but not with crystal or ceramic mics because the IC input impedance is too low. Note that all four circuits are identical, but that only one is shown complete. So, 2-channel panning circuit, CMOS mixer, mixer preamp with tone control, general purpose preamplifier / mixer, accepts up to 4 inputs, has a gain of 1600 and provides bass and treble controls that can be varied plus or minus 10 decibels at 100 Hz and 10 kHz respectively. IC1 and IC2 are the LM301A. Got a passive mixer. It's just a couple of resistors, isn't it? 1 transistor audio mixer. Uses an amplifier. 3 or more inputs with individual level controls feed into the base of Q1 that provides a voltage gain of 20. Silent audio switching / mixing. 2 or more signals can be switched and or mixed without annoying clicks by using FETs and a low impedance op-amp circuit. Hybrid mixer. 4-channel mixer. Audio oscillators. The sources of we know about that. The Wien bridge oscillator, Wien bridge oscillator, Wien bridge oscillator. Very low frequency generator. Audio oscillator, sine wave oscillator, easy tune sine / square wave oscillators, Wien bridge sine wave oscillator, phase shift oscillator, tone encoder, feedback oscillator, phase shift oscillator, 800 Hz oscillator, tunable single comparator oscillator, wide range oscillator, frequency range of 500 to 1, Wien bridge oscillator, Wien bridge sine wave oscillator. This is the Wien bridge oscillator using the Micro A777. Okay. Circuit notes. Field effect transistor Q1. Operates in the linear resistive region to provide automatic gain control. Because the attenuation of the RC network is 1/3 at the 0 phase shift oscillation frequency, the amplifier gain determined by resistor R2 and equivalent resistor R1 must be just equal to 3 to make up the unity gain positive feedback requirement needed for stable oscillation. Resistor R3 and R4 are set to approximately 1 kilo ohm less than the required R1 resistance. The FET dynamically provides the trimming resistance needed to make R1 1/2 of the resistance of R2. The circuit composed of R5, D1 and C1 isolates, rectifies and filters the output sine wave, converting it to a DC potential to control the gate of the FET. For the low drain to source voltages used, the FET provides a symmetrical linear resistance for a given gate to source voltage. And we've got another Wien bridge oscillator. Wien bridge sine wave oscillator using 2 RCA CA3140 op-amps covers 30 Hz to 100 kHz with less than 0.5% total harmonic distortion. The 10K pot is adjusted for the best waveform. Capacitor C1 and C2 are 2-gang 450 picofarad variable with its frame isolated from ground. Maximum output into a 600 ohm load is about 1 volt RMS. Wien bridge oscillator, another one. This one's using some integrated circuits for the amplifiers there. Very low frequency generator. Wien bridge oscillator generates frequencies of 1 Hz and 2 to 20 Hz in 2 Hz steps. Maximum output amplitude is 3 volts RMS of 8.5 volts peak to peak. A pot and switch attenuator allows the output level to be set with a fair degree of precision to any value within a range of 5 decades. Audio oscillator. Almost any transistor will work. R1 and C1 will vary the tone. Yeah, okay. It's a pretty boring oscillator, isn't it? Sine wave oscillator. The oscillator delivers a high purity sinusoid with a stable frequency and amplitude. Okay, cool. Easily tuned sine/square wave oscillators. This circuit will provide both a sine and a square wave output for frequencies from below 20 Hz to above 20 kHz. The frequency of oscillation is easily tuned by varying a single resistor. Wire and bridge sine wave oscillator. Using the SN5457 JFET as a voltage variable resistor in the amplifier feedback loop produces a low distortion, constant amplitude sine wave, getting the amplifier loop gain just right. The LM103 Zener diode provides the voltage reference for the peak sine wave amplitude. Phase shift oscillator. Circuit uses a simple RC network to produce an exceptionally shrill tone from a miniature speaker. With the part values shown, the circuit oscillates at a frequency of 3.6 kHz and drives a miniature 2.5-inch speaker with ear-piercing volume. The output waveform is a square wave with a width of 150 microseconds, sloping rise and fall times, and a peak-to-peak amplitude of 4.2 volts when powered by 9 volts. Current drain of the oscillator is 90 milliamps at 9 volts, and total power dissipation at this voltage is 0.81 watts, which is well below the 1.25 watts the 14-pin version will absorb at room temperature before shutting down. Tone encoder. Feedback oscillator. Circuit oscillates because the transistor shifts the phase of the signal 180 degrees from the base to the collector. Each of the RC networks in the circuit is designed to shift the phase 60 degrees at the frequency of oscillation for a total of 180 degrees. The appropriate values of R and C for each network is found from F equals 1/2 the square root of 3 times pi RC. That equation follows for the 60 degrees phase shift required by the design. Yeah, that's fun. Phase shift oscillator. 800 Hz oscillator. These are pretty simple, like RC networks with just bijunction BJT transistors. Tunable single comparator oscillator. Wide range oscillator, frequency range of 5,000 to 1. That's fun. Wire and bridge oscillator using the LM358. Wire and bridge sine wave oscillator using the LM118. And we're up to audio power amplifiers, chapter 8. I'm going to go get more coffee. I'll be back. All right, I'm back. So got myself a fresh coffee. We're up to chapter 8. Chapter 8 is audio power amplifiers. Low cost 20 watt audio amplifier, 75 watt audio amplifier with load line protection, bridge amplifier, non-inverting amplifier using single supply, non-inverting amplifier using split supply, 6 watt 8 ohm output transformerless amplifier, 12 watt low distortion power amplifier, 10 watt power amplifier, stereo amplifier with AV equals 200, AM radio power amplifier, 470 milliwatt complementary symmetry audio amplifier, novel loudspeaker coupling circuit, non-inverting AC power amplifier, inverting power amplifier, non-inverting power amplifier, 4 watt bridge amplifier, phono amplifier with a common mode volume and tone with control, phono amplifier, phonograph amplifier, ceramic cartridge, inverting unity gain amplifier, bridge audio power amplifier, phono amplifier, high slew rate power op amp / audio amp, and a 16 watt bridge amplifier. So this is the, I might see if I can get something. How about that? Yeah, that'll do. So this is the low cost 20 watt audio amplifier. Some diodes, BJTs, potentiometers. Yeah, okay. Looks like there's some integrated circuit there, the SE9401, is it? It's a pretty simple circuit. This simple, inexpensive audio amplifier can be constructed using a couple of TO220 monolithic Darlington transistors. Yeah, these are the Darlingtons in here. Yeah, right. For the push-pull output stage, frequency response is flat within 1 decibel from 30 Hz to 200 kHz, with typical harmonic distortion below 0.2%. The amplifier requires only 1.2 volt RMS for a full 20 watt output into an 8 ohm load. Only one other transistor is needed, the TO92 low noise high gain 2N5961. That's the NPN transistor here. To provide voltage gain for driving the output Darlingtons, its base point B is the tie point for AC and DC feedback, as well as for the signal input. Input resistance is 10 kilo ohms. The center voltage at point A is set by adjusting R4. A bootstrap circuit boosts the collector supply voltage of Q1. Point C. Where's point C? There's A and there's B. I'm not seeing C. There it is, all the way up there. Alright, to ensure sufficient drive voltage for Q2, this also provides constant voltage across R7, which therefore acts as a current source, and together with diodes D1 to D3 reduces low signal crossover distortion. This one is 75 watt audio amplifier with load line protection. Bridge amplifier, non-inverting amplifier using single supply, non-inverting amplifier using split supply. Yeah, you can see the supply here and the supply here. So it's got a positive and a negative reference in the split supply. Interesting. So what do we got next? 6 watt 8 ohm output transformerless amplifier. 12 watt low distortion power amplifier. 10 watt power amplifier. Uses the LM378. Stereo amplifier with AV equals 200, using the LM1877. AM radio power amplifier, using the LM390. 470 milliwatt complementary symmetry audio amplifier. This circuit has less than 2% distortion and is flat within 3 decibels from 15 Hz to 130 kHz. Novel loudspeaker coupling circuit. The ground side of the speaker is connected to the junction of the 2 equal high-value capacitors. 1000 microfarads is typical. Across the supply, the amplifier output voltage will be Vs on 2, and so will the voltage across C1 if C1 and C2 are equal. So as the supply voltage builds up, the DC voltage across the speaker will remain 0, eliminating the switch on surge. C1 and C2 will also provide supply smoothing. The circuit is shown with the LM380, but could be applied to any amplifier circuit, providing that the DC voltage at the output is half the supply voltage. Non-inverting AC power amplifier, non-inverting power amplifier, inverting power amplifier. and a 4-watt bridge amplifier. Phono amplifier with common mode volume and tone control. Phonograph amplifier, ceramic cartridge. Don't know what the ceramic cartridge is, some sort of an output, I don't know. Or maybe it's got to do with this crystal here, volume control. Phono amplifier. Inverting unity gain amplifier. Bridge audio power amplifier. Phono amplifier. Used when maximum input impedance is required, or the signal attenuation of the voltage divider volume is undesirable. Used when maximum input impedance is required or the signal attenuation of the voltage divider volume control is undesirable. High slew rate power op amp audio amp. Okay. And 16-watt bridge amplifier. Audio signal amplifiers. General purpose preamplifier. What is an audio signal? Is it like, say, 100 hertz through to like 100 kilohertz? 20 kilohertz? I'm not sure. I might go look that up. Hang on a sec. Yep, humans can hear 20 hertz to 20 kilohertz, roughly. Of course, assuming that they have the faculty of hearing. Not everyone does. So, again, this is the audio signal amplifiers. General purpose preamplifier, basic transistor amplifier circuits, microphone amplifier, transducer amplifier, ultra high gain audio amplifier, transformerless microphone preamp, balanced inputs, transformerless microphone preamp, unbalanced inputs, magnetic pickup phone preamplifier, disc/tape phase modulated readback systems, 2-pole fast turn on NAB tape preamplifier, tape preamplifier NAB equation, LM382 phono preamplifier, tape recording amplifier, magnetic phono preamplifier, phono preamp, remote amplifier, adjustable gain non-inverting amplifier, high gain inverting AC amplifier, flat response amplifier, preamplifier with RIAA/NAB compensation, and tape playback amplifier. So this is a general purpose preamplifier using the LM382. Not much can be said about how the LM382 works, as most of the circuitry is contained within the IC. Most of the frequency determining components are on the chip, only the capacitors are mounted externally. The LM382 has the convenient characteristic of rejecting ripple on the supply line by about 100 decibels, thus greatly reducing the quality requirement for the power supply. All right. Basic transistor amplifier circuits. Okay, so there we go. We've got a common base, common emitter, and common collector. Common base, common emitter, and common collector. I feel like this is important. Is this important? I'm going to scan this. I'll be back. All right, well, I scanned this one, and I'll put it in the show notes. So what I noticed is that the common emitter is an inverting amplifier. It inverts the signal. The other two don't seem to do that. So there you go. Electronic balanced input microphone amplifier. Okay. Transducer amplifier. This circuit is high input impedance AC amplifier for a piezoelectric transducer. Input resistance is 880 mega ohms. Wow, that's huge. And a gain of 10 is obtained. Ultra high gain audio amplifier, sometimes called the JFET microamp. This circuit provides a very low power, high gain amplifying function. Since mu of a JFET increases as drain current decreases, the lower drain current is, the more gain you get. Input dynamic range is sacrificed with increasing gain, however. Microphone amplifier. This circuit operates from a 1.5 volts DC source. Okay. Transformerless balance inputs microphone preamp. Transformerless microphone preamps unbalanced inputs. Magnetic pickup phono preamplifier. Disc tape phase modulated readback systems. 2-pole fast turn on nab tape preamplifier. LM382 phono preamplifier. I'll just look up what NAB and RIAA mean. All right, so NAB and RIAA, they're standards organizations. So they're National Association of Broadcasters and the Record Industry Association. So yeah, obviously they publish some sort of standards about sound or something. So there you go. This is the tape recording amplifier. Okay. Magnetic phono preamplifier. Remote amplifier. Phono preamp. RIAA equalization. Adjustable gain non-inverting amplifier. High gain inverting AC amplifier. Preamplifier with RIAA/NAB compensation. Flat response amplifier, fixed gain configuration, and tape playback amplifier. Automotive circuits. Gasoline engine tachometer, speed alarm, speed warning device, universal wiper delay, courtesy light extender, bar graph car voltmeter, tachometer, high speed warning device, breaker point dwell meter, tachometer, capacitor discharge ignition system, windshield wiper control, auto battery current analyzer, speed switch, windshield wiper controller, windshield wiper hesitation control unit, ice warning and lights reminder, car battery monitor, headlight delay unit, windshield washer fluid watcher. Great. Car battery condition checker, overspeed indicator, sequential flasher for auto turn signals, auto lights on reminder. Okay, this is the gasoline engine tachometer. This tachometer can be set up for any number of cylinders by linking the appropriate timing resistor as illustrated. A 500 ohm trim resistor can be used to set up final calibration. A protection circuit composed of a 10 ohm resistor and a Zener diode is also shown as a safety precaution against the transients which are to be found in automobiles. Speed alarm. Circuit notes. Pulses from the distributor points are passed through a current limiting resistor, rectified and clipped at 4.7 volts. via Q1 and the diode pump, a DC voltage proportional to engine RPM is presented to RV1. The sharp transfer characteristic of a CMOS gate assisted by feedback is used to enable the oscillator formed by the remaining half of the 4011. At the preset speed, a non-ignorable tone emits from the speaker and disappears as soon as the speed drops by 3 or 4 miles per hour. There you go. Speed warning device uses some 555 timers. Operating waveforms. Universal wiper delay, again with the 555 timer. IC1 is connected in the astable mode, driving RLA. C3, D1 and D2 prevent spikes from the relay coil and the wiper motor from triggering IC1. VR2, where's VR2? Oh, the variable resistors. Is adjusted to give the minimum delay time required. VR1 is the main delay control and provides a range from about 1 second to 20 seconds. SW1 is an override switch to hold RLA permanently on for normal wiper operation. The relay should have a resistance of at least 150 ohms and have heavy-duty contacts. The suppression circuit may be needed for the protection of IC1. Courtesy light extender. Most car door switches are simply single pole switches with one side grounded. When the door is open, the switch grounds the other line, thus completing the light circuit. In a car where the negative terminal of the battery is connected to the chassis, the negative wire of the unit, the emitter of Q2, is connected to chassis. The positive wire, case of 2N3055, is connected to the wire going to the switch. In a car having a positive ground system, this connection sequence is reversed. When the switch closes, the door open, C1 is discharged via D1 to 0 volts, and when the switch opens, C1 charges up via R1 and R2. Transistors Q1 and Q2 are connected as an emitter follower. Q2 just buffers Q1. Therefore, the voltage across Q2 increases slowly as C1 charges, hence Q2 acts like a resistance in parallel with the switch and keeps the lights on. The value of C1 is chosen such that a useful light level is obtained for about 4 seconds. Therefore, the light decreases until in about 10 seconds it is out completely. With different transistor gains and with variation in current drain due to a particular type of car, the timing may vary but may be simply adjusted by selecting C1. Bar graph car voltmeter. Okay, it uses LEDs and LM3914 IC. So it shows anything from 10.5 volts to 15 volts. The LM3914 acts as a LED driving voltmeter that has its basic maximum and minimum readings determined by the values of R2 and RV2. When correctly adjusted, the unit actually covers the 2.5 volt to 3.6 volt range, but is made to read a supply voltage span of 10 to 10.5 volts to 15 volts by interposing potential divider R1, RV1 between the supply line and the pin 5 input terminal of the integrated circuit. The IC is configured to give a dot display in which only one of the 10 LEDs is illuminated at any given time. If the supply voltage is below 10.5 volts, none of the LEDs illuminate. If the supply equals or exceeds 15 volts, LED 10 illuminates. A tachometer. What sort of a sensor does it have? Input from points. An electrical signal taken from the low tension side of the distributor is converted into a voltage proportional to the engine RPM, and this voltage is displayed on a meter calibrated accordingly. Uses a 555 timer. I'm not sure where the output is. Must be here, some sort of a meter. 1 milliamp FSD. High speed warning device. A1 amplifies and regulates the signal from the spark coil. A2 converts frequency to voltage so that its output is voltage proportional to engine RPM. Okay. Breaker point dwell meter. Tachometer. Capacitor discharge ignition system. Interesting. Windshield wiper control. Here's a good way to set windshield wipers on an interval circuit. Only 2 connections to the car's wiper control plus ground are required. Variable control can be accomplished by substituting a 500 kilo ohm pot in series with a 100 kilo ohm fixed resistor in place of the 560K. Auto battery current analyzer. Speed switch. Windshield wiper controller. Windshield wiper hesitation control unit. This circuit uses the 555 timer in the astable or oscillatory mode. The length of time the timer is off is a function of the values C1, R2, and R3. The potentiometer, which controls the amount of hesitation, approximately 2 to 15 seconds. R2 provides a minimum time delay when R3 is at 0 ohms position. Ice warning and lights reminder. Uses a thermistor, there we go, so that's how that works, temperature controlled. Circuit notes, car battery monitor. Okay. Headlight delay unit. This circuit will operate a car's headlights for a predetermined time to light up the driveway or path after the driver has left the car. Okay. Windshield washer fluid watcher. Yeah, that's pretty handy. Pretty simple. It's just a Darlington transistor in there. Silicon-controlled rectifier. Car battery condition checker. Overspeed indicator. Sequential flasher for automotive turn signals. Auto lights on reminder. The alarm is composed of a diode, buzzer, and limiting resistor. The diode serves as a switch, which allows the buzzer to sound off only when the light switch is closed and the ignition is turned off. There you go. Pretty simple. Battery chargers. 12-volt battery charger, simple NiCad battery charger, 12-volt battery charge control, 20 amps RMS max, battery charger, automatic shut-off battery charger, 200 milliamp hour, 12-volt NiCad battery charger, NiCad charger with current and voltage limiting, automotive charger for NiCad battery packs, constant voltage, current limited charger, NiCad charger, simple NiCad battery zapper, battery charging regulator, low cost trickle charger for 12-volt storage battery, fast charger for NiCad batteries, current limited 6-volt charger. Well, they didn't have lithium batteries back in the 80s, did they? It was all NiCad, maybe lead acid as well in the car. What do we got here? This circuit is a high performance charger for gelled electrolyte lead acid batteries. Charger quickly recharges battery and shuts off at full charge. Initially, charging current is limited to 2 amps. As the battery voltage rises, current to the battery decreases. And when the current has decreased to 150 milliamps, the charger switches to a lower flat voltage, preventing overcharge. When the start switch is pushed, the output of the charger goes to 14.5 volts. As the battery approaches full charge, the charging current decreases and the output voltage is reduced from 14.5 volts to about 12.5, terminating the charging. Transistor Q1 then lights the LED as a visual indication of full charge. So it uses an LM301 and an LM350. Not clear what the LM350 is. The LM301 seems to be some sort of an amplifier. Apart from that, there's just a transistor, BJT, PMP. There's a button to start it. Alright, simple NiCad battery charger. This circuit provides an adjustable output voltage up to 35 volts DC and maximum output current of 50 milliamps. Transistor Q1 dissipates quite a bit of heat and must be mounted on a heatsink. There you go. 12 volt battery charger control, 20 amps RMS max. Battery charger. A diac is used in the gate circuit to provide a threshold level for firing the triac. Oh man, I don't use those components very often. Sorry, I wasn't calling out the things. This is a simple NiCad battery charger. This is a 12 volt battery charger control, 20 amps RMS max. I've got a battery charger over here, automatic shut-off battery charger. Again, the triacs and the silicon controlled rectifiers, Zener. 200 milliamp hour 12 volt NiCad battery charger. This circuit charges the battery at 75 milliamps until the battery is charged, then it reduces the current to a trickle rate. It will completely recharge a dead battery in 4 hours, and the battery can be left in the charger indefinitely. To set the shutoff point, connect a 270 ohm 2 watt resistor across the charge terminals and adjust the pot for 15.5 volts across the resistor. NiCad charger with current and voltage limiting. Automotive charger for NiCad battery packs. Constant voltage current limited charger for 12 volt sealed lead acid batteries. Powered off the mains. NiCad charger. This circuit uses constant current LEDs to adjust charging current. It makes use of LEDs that pass a constant current of about 15 milliamps for an applied voltage range of 2 to 18 volt. They can be paralleled to give any multiple of 15 milliamps, and they light up when current is flowing. The circuit will charge a single cell at 15, 30 or 45 milliamp, or cells in series up to the rated supply voltage limit of about 14 volts. Simple NiCad battery zapper. This circuit is used to clear internal shorts in nickel-cadmium batteries. To operate, connect NiCad to output and press the push button for 3 seconds. Yeah, right. Battery charging regulator. The circuit is capable of charging a 12 volt battery up to a 6 ampere rate. Other voltages and currents from 6 to 600 volts and up to 300 amps can be accommodated by suitable component selection. When the battery voltage reaches its fully charged level, the charging SCR shuts off and a trickle charge is determined by the value of R4. Low-cost trickle charger for 12 volt storage battery. Wow. It just uses a bulb to chew up. Oh dear. I don't like the look of that. The low cost fast charger for NiCad batteries. Current limited 6 volt charger. Battery monitors. Solid state battery voltage indicator, NiCad discharge limiter, battery condition indicator, equipment on reminder, batteries charge / discharge indicator, precision battery voltage monitor for HTs. I don't know what HT is. Low voltage monitor, under voltage indicator for battery operated equipment, low battery indicator, battery level indicator, battery threshold indicator. Solid state battery voltage indicator. Okay, so this just uses Zener diodes. NiCad discharge limiter. The circuit disconnects the battery from the load when output voltage falls below a preset level. C1 charges through R1 and turns on Q2. Collector current flows through R2, turning Q1 on, and battery is connected to the load. When the output voltage falls below a point set by RV1, Q2 turns off, Q1 turns off, and further discharge of the battery is prevented. There you go. Battery condition indicator using a 741 op amp. A 741 op amp is employed as a voltage comparator. The non-inverting input is connected to a Zener reference source. Reference voltage is 5.1 volts. R2 is adjusted so that the voltage of the inverting input is half the supply voltage. When supply is higher than 10.2 volt, the LED will not light. When the supply falls just fractionally below the 10.2 volt level, the IC inverting input will be slightly negative of the non-inverting input, and the output will swing fully positive. The LED will light, indicating that the supply voltage has fallen to the preset threshold level. The LED can be made to light at other voltages by adjusting R2. Equipment on reminder. Due to the low duty cycle of flashing LED, the average current drain is 1 milliamp or less. Battery charge discharge indicator. Precision battery voltage monitor for HTS. Circuit notes. I don't know what HT stands for. The precision voltage monitor chip contains a temperature compensated voltage reference. R1 divides the HT maybe for high temperature. I don't know. R1 divides down the battery voltage to match the built-in reference voltage of IC1, 1.15 volts. When the voltage at pin 3 falls below 1.15 volts, pin 4 supplies a constant current of about 7 milliamps to drive a small LED. About 0.2 volt of hysteresis is added with R2. Without hysteresis, the LED could flicker on and off when the monitored voltage varies around the set point, as might be the case on voice peaks during receive. HT battery, HTB plus line. I don't know what it is. Home telephone? I don't know. Low voltage monitor. Under voltage indicator for battery operated equipment. Low battery indicator. Battery level indicator. Battery threshold indicator. Buffers. Sine wave output buffer amplifier, single supply AC buffer amplifier, single supply AC buffer, high speed 6-bit analog digital buffer, high impedance low capacitance wideband buffer, high resolution ADC input buffer, 100 times buffer amplifier, 10 times buffer amplifier, stable high impedance buffer, and high speed single supply AC buffer. Sine wave output buffer amplifier, single supply AC buffer amplifier, single supply AC buffer high speed, high impedance, low capacitance wideband buffer. The 2N5485 has low input capacitance, which makes this compound series feedback buffer a wideband unity gain amplifier. High speed 6-bit AD buffer. TRW TDC 1014J. High resolution ADC input buffer. 100 times buffer amplifier. Stable high impedance buffer. Input impedance is 200 gigaohms. Wow, that is high impedance. 10 times buffer amplifier. High speed single supply AC buffer. Capacitance operated circuits, also known as touch circuits. Capacitance relay, capacitance operated battery powered light, touch sensitive switch, low current touch switch, capacitance switch light, momentary operation touch switch, touch triggered bistable, capacitance operated alarm to foil purse snatchers, self-bias proximity sensor works on detected changing fields, touch switch or proximity detector, finger touch, or control switch. That's a typo. Proximity detector, touch circuit, CMOS touch circuit, latching double button touch switch. Capacitance relay. Capacitance operated battery powered light. Touch sensitive switch. Low current touch switch. Capacitance switch light. Momentary operation touch switch. Touch triggered bistable. This circuit uses a 555 timer in the bistable mode. Touching T2 causes the output to go high, D2 conducts and D1 extinguishes. Touching T1 causes the output to go low, D1 conducts and D2 is cut off. The output from pin 3 can also be used to operate the other circuits, for example a triac controlled lamp. In this case, the LEDs are useful for finding the touch terminals in the dark. C1 is not absolutely necessary, but helps to prevent triggering from spurious pulses. Capacitance operated alarm to foil purse snatchers. As long as touch plates 1 are touched together, the alarm is off. If not held for about 30 seconds, the alarm goes off. The circuit can be disabled with switch or by touching the plates. The alarm is battery operated by a bicycle horn. Alright. Self-bias proximity sensor works on detected changing field. Touch switch or proximity detector. This circuit is actuated by an increase in capacitance between a sensing electrode and the ground side of the line. The sensitivity can be adjusted to switch when a human body is within inches of the insulated plate used as the sensing electrode. Thus, sensitivity is adjusted with the 1 megaohm potentiometer, which determines the anode voltage level prior to clamping. This sensitivity will be proportional to the area of the surface opposing each other. Finger touch or contact switch, proximity detector, touch circuit, CMOS touch switch. latching double button touch switch. So you get touch on, touch off. Chapter 15, carrier current circuits. FM carrier current remote speaker system, 200 kilohertz line carrier transmitter with on-off carrier modulation, carrier current receiver, carrier current transmitter, carrier current transmitter, integrated circuit current transmitter, single transistor carrier current receiver, IC carrier current receiver, carrier current remote control or intercom. Carrier current. Don't know anything about this. FM carrier current remote speaker system. High quality, noise free, wireless FM transmitter / receiver operates over standard power lines. So this current carrier seems to be power line networking. Complete system is suitable for high quality transmission of speech or music and will operate from any AC outlet anywhere on a 1 acre home site. Frequency response is 20 to 20 kilohertz and THD is under 0.5%. Is that total harmonic distortion? I'm not sure. Transmission distance along a power line is at least adequate to include all outlets in and around a suburban home and yard. 2 input terminals are provided so that both left and right signals of a stereo set may be combined for mono transmission to a single remote speaker if desired. Carrier system, okay, and there's 2 parts, a transmitter and a receiver. The receiver amplifies, limits, and demodulates the received FM signal. It provides audio mute in the absence of carrier and 2.5 watt output to a speaker. Fascinating. This is 200 kilohertz line carrier transmitter with on-off carrier modulator. Okay, carrier current receiver. 160 kilohertz transformer consists of an 18 by 11 millimeter ungapped pot core, utilizing magnetics incorporated type F material wound with 80.5 turns of number 35 wire for the secondary and 5.5 turns for the primary. This gives a term ratio of approximately 15:1. Carrier current transmitter. Carrier current transmitter. Carrier current transmitter. Single transistor carrier current receiver. IC carrier current receiver. Carrier current remote control or intercom. Now this is a 567. I don't know what that is. Comparators. Null detector, comparator with variable hysteresis, diode feedback comparator, undervoltage overvoltage indicator, dual limit comparator, high-low limit alarm, window comparator driving high-low lamps, comparator with timeout, non-inverting comparator with hysteresis, inverting comparator with hysteresis, window comparator, micro power double-ended limit detector, opposite polarity input voltage comparator, limit comparator, comparator clock circuit, double-ended limit comparator, precision dual limit go no-go tester, comparator with hysteresis, high impedance comparator, and comparator. This is a null detector. It's got the 741 op amp in there. Okay. Null detector uses simple LED readout to indicate if test resistor Rx is below, equal to, or greater than test resistance Rf. If Rx equals Rf, the 741 output sits at midpoint value of 4.5 volts and LED AA lights. Otherwise, the output of the 741 turns off one transistor and diverts current from the other transistor through B or C, depending on the polarity of the input voltage difference. Null detector response is illustrated. This is it here, right? Comparator with variable hysteresis without shifting initial trip point. An operational amplifier can be used as a convenient device for analog comparator applications that require two different trip points. The addition of a positive feedback network introduces a precise variable hysteresis into the usual comparator switching action. Such feedback develops two comparator trip points centered about the initial trip point or reference point. The voltage difference, delta V, between the trip points can be established by varying resistor R2. When the output voltage is taken from the Zener diode as shown, it switches between 0 and Vz, the Zener voltage. Diode feedback comparator, under voltage over voltage indicator, dual limit comparator, high-low limit alarm. Window comparator. Window comparator driving high-low lamps. Comparator with timeout. The MC1422 is used as a comparator with the capability of a timing output pulse when the inverting input pin 6 is greater than or equal to the non-inverting input pin 5. The frequency of the pulses for the values of R2 and C1 is shown approximately 2 Hz and the pulse width 0.3 milliseconds. Non-inverting comparator with hysteresis. Inverting comparator with hysteresis. Window comparator. Micro power double-ended limit detector. It uses the CD4011. It looks like it's some sort of an AND gate. It says here it's a NAND. So that must be that. I'm not sure. Opposite polarity input voltage comparator. Limit comparator. Double-ended limit comparator. Comparator clock circuit. Limit comparator. Precision dual limit go-no-go tester. High impedance comparator. Comparator with hysteresis. Comparator. An operational amplifier is used as a comparator which is capable of driving approximately 10 logic gates. It must be talking about TTL, do you think? Transistor logic, when it talks about logic? Probably. I'm not sure. Converters. The sources of the following circuits are contained in the sources section, blah, blah, blah. Okay, pico amp to frequency converter, BCD to analog converter, resistance to voltage converter, low cost micro P interface temperature to digital converter, high-low resistance to voltage converter, current to voltage converter, calculator to stopwatch converter, Power voltage to current converter, high impedance precision rectifier for AC-DC converter, wide range current to frequency converter, AC to DC converter, current to voltage converter with 1% accuracy, polarity converter, voltage to current converter, wideband high crest factor RMS to DC converter, light intensity to frequency converter, ohms to volts converter, temperature to frequency converter, multiplexed BCD to parallel BCD converter, fast logarithmic converter, sine wave to square wave converter, self-oscillating flyback converter, TTL to MOS logic converter. There you go. Picoampere to voltage converter with gain. All right, this is picoampere to frequency converters. All right. So we've got the LF351 and the LM331 and a bunch of BJTs. So frequency out 100 kilohertz full scale output. Okay. 1 microamp full scale. So here's the current input, and then there's the frequency output. Fair enough. BCD to analog converter. There you go. This circuit will convert 4-bit BCD into a variable voltage from 0 to 9 volts in 1 volt steps. The SN74141 is a Nixie driver and has 10 open collector outputs. These are used to ground a selected point in the divider chain determined by the BCD code at the input, and so produce a corresponding voltage at the output. Accuracy of the circuit depends on the tolerance of the resistors and the accuracy of the reference voltage. However, presets can be used in the divider chain with correct calibration. The 741 is used as a buffer. Resistance to voltage converter. Circuit will measure accurately to 20 megaohms when associated with a buffer amplifier A1 having a low input bias current, less than 30 nanoamps. The circuit uses 2 of the 3 amplifiers contained in the Siliconics L144 micro power triple op amp. There you go. Low cost micro P interface temperature to digital converter. Not much to say about that. High-low resistance to voltage converter. Current to voltage converter. Converter features 8 decades of current range. The circuit is intended to be used with the 200 millivolt range of a DVM. Right, I see. So okay, I see. Calculator to stopwatch converter. This circuit can be fitted to any calculator with an automatic constant to enable it to be used as a stopwatch. The 555 timer is set to run at a suitable frequency and connected to the existing calculator battery via the push-on push-off switch and the existing calculator on-off switch. I don't understand how this works. Power voltage to current converter. Low-cost converter is capable of supplying constant AC currents up to 1 amp over variable loads. Voltage to current, there you go. High impedance precision rectifier for AC DC converter. Wide range current to frequency converter. Current to frequency. AC to DC. Okay. Current to voltage converter with 1% accuracy. A filter removes the DC component of the rectified AC, which is then scaled to RMS. The output is linear from 40 Hz to 10 kHz or higher. Polarity converter. The capacitor diode output circuit is used here as a polarity converter to generate a -5 volt supply from a +15 volts. This circuit is useful for an output current of up to 20 milliamps with no additional boost transistors required. Since the output transistors are current limited, no additional protection is necessary. Also, the lack of an indicator allows the circuit to be stabilized with only the output capacitor. Voltage to current converter. Wideband high crest factor RMS to DC converter. Light intensity to frequency converter. Ohms to volts converter. Temperature to frequency converter. Multiplexed BCD to parallel BCD converter. Fast logarithmic converter. Sine wave to square wave converter. TTL to MOS logic converter. Self-oscillating flyback converter. Picoampere to voltage converter with gain. Crossover networks. Active crossover network, asymmetrical third order Butterworth active crossover network, third order Butterworth crossover network. Asymmetrical third order Butterworth active crossover network. Third order Butterworth crossover network. Crystal oscillators. Holy cow, there's a lot of these. High frequency crystal oscillator. Overtone crystal oscillator, overtone crystal oscillator, TTL oscillator for 1 MHz to 10 MHz, crystal checker, 96 MHz crystal oscillator, simple TTL crystal oscillator, overtone crystal oscillator, Schmidt trigger crystal oscillator, 50 MHz to 150 MHz overtone oscillator, fifth overtone oscillator, crystal controlled Butler oscillator, overtone oscillator with crystal switching, crystal oscillator / doubler, low frequency crystal oscillator, 100 kHz crystal calibrator, third overtone crystal oscillator, crystal checker, CMOS crystal oscillator, temperature compensated crystal oscillator, crystal controlled transistor oscillator, Pierce harmonic oscillator, Colpitt's harmonic oscillator, International Crystal OF1 LO oscillator, Butler emitter follower oscillator, Colpitt's harmonic oscillator, Butler emitter follower oscillator, Butler common base oscillator, Pierce harmonic oscillator, tube type crystal oscillator, precision clock generator, Miller oscillator, Butler emitter follower oscillator, Colpitt's oscillator, crystal controlled oscillator, Pierce oscillator, Butler aperiodic oscillator, parallel mode aperiodic crystal oscillator, International Crystal OF1 HI high oscillator, standard crystal oscillator for 1 MHz, TTL compatible crystal oscillator, crystal controlled sine wave oscillator, crystal oscillator, stable low frequency crystal oscillator, JFET Pierce crystal oscillator, CMOS oscillator, Pierce harmonic oscillator. Wow, that's a lot of oscillators. I think we're just going to flip through these pretty quickly. I suppose I might as well keep calling them out to you. This is the 5th overtone oscillator, crystal controlled Butler oscillator, overtone oscillator with crystal switching, crystal oscillator slash doubler, low frequency crystal oscillator, 100 kilohertz crystal calibrator, 3rd overtone crystal oscillator, crystal checker, CMOS crystal oscillator, temperature compensated crystal oscillator, crystal controlled transistor oscillator, Pierce harmonic oscillator, Colpitt's harmonic oscillator 100 megahertz, international crystal OF1 low oscillator, Butler emitter follower oscillator 100 megahertz, Colpitt's harmonic oscillator basic circuit, Butler emitter follower oscillator, Butler common base oscillator, Pierce harmonic oscillator, tube type crystal oscillator, precision clock generator, Miller oscillator, Butler emitter follower oscillator 20 megahertz, Colpitt's oscillator, crystal controlled oscillator, Pierce oscillator, Butler aperiodic oscillator, parallel mode aperiodic crystal oscillator, international crystal OF1 high oscillator, standard crystal oscillator for 1 megahertz, TTL compatible crystal oscillator, crystal controlled sine wave oscillator, stable low frequency crystal oscillator, JFET Pierce crystal oscillator, CMOS oscillator 1 megahertz to 4 megahertz, Pierce harmonic oscillator 100 megahertz. And now we're up to chapter 20, current measuring circuits. Ammeter, pico ammeter, nano ammeter, nanoampere sensing circuit with 100 mega ohm input impedance, current monitor. Wow. Current meter ranges from 100 picoamps to 3 milliamps full scale. Voltage across input is 100 microvolts at lower ranges, rising to 3 millivolts at 3 milliamps. The buffers on the op-amp are to remove ambiguity with high current overload. The output can also drive a DVM or a DPM. DVM is a digital voltmeter. A DPM, I'm not sure what that is. Pico ammeter, nanoammeter, nanoampere sensing circuit with 100 mega ohm input impedance. Current monitor. Current sources and sinks. Current source, precision current source, precision 1 microamp to 1 milliamp current sources, precision current sink. Alright, so there's a current source using an A1LM11C. And this one, precision current source, is using an LM101 and a 2N5457 and a PN2222. It's good old 2222. Precision 1 microamp to 1 milliamp current sources. Precision current sink. DC-DC and DC-AC converters. DC to DC AC inverter. DC to DC SMPS using NE5561 variable 18 volt to 30 volt out at 0.2 amps. Mini power inverter as high voltage low current source. Regulated DC to DC converter. 500 volt 60 watt push pull DC DC converter. DC DC regulating converter, and a flyback converter. DC to DC inverter. DC to DC SMPS using NE5561 variable 18 volt to 30 volt out at 0.2 amps. Mini power inverter as high voltage low current source. Regulated DC to DC converter. Okay. Low power DC to DC converter obtained by adding a flyback circuit to a Squarewave oscillator. Operating frequency is 20 kHz to minimize the size of L1 and C2. Regulation is achieved by Zener diode D2. Maximum current available before the converter drops out of regulation is 5.5 milliamps. 400 volt 60 watt push pull DC DC converter. DC DC regulating converter. Flyback converter. Low current flyback converter is used here to generate plus or minus 15 volts at 20 milliamps from a plus 5 regulated line, plus 5 volt regulated line. The reference generator in the SG1524 is unused, with the input voltage providing the reference. Current limiting is in a flyback converter is difficult and is accomplished here by sensing current in the primary line and resetting a soft start circuit. Decoders. Tone alert decoder. Tone decoder with relay output. SCA decoder. 10.8 MHz FSK decoder. 24% bandwidth tone decoder and dual tone decoder. Dual, that's probably DTMF. Tone alert decoder. PLL U1 is set with R2 to desired tone frequency. LED lights to indicate lockup of PLL, that's a phase lock loop. Reduce signal level R1 and readjust R2 to assure lockup. Delay is selected from counter U3 output. Circuit latches, turns on Q1 to allow audio to speaker when proper frequency duration signal is received. To reset latch, a positive voltage must be applied briefly to the R input of U4. This is a tone decoder with relay. Okay. SCA, background music decoder. I wonder what that means. A resistive voltage divider is used to establish a bias voltage for the input pins 2 and 3. The demodulated multiplex FM signal is fed to the input through a two-stage high-pass filter, both to effect capacitive coupling and to attenuate the strong signal of the regular channel. A total signal amplitude between 8 mV and 300 mV is required at the input. Its source should have an impedance of less than 10k ohms. The phase lock loop is tuned to 67 kHz with a 5000 ohm potentiometer. Only approximate tuning is required since the loop will seek the signal. The demodulated output pin 7 passes through a 3-stage low-pass filter to provide de-emphasis and attenuate the high-frequency noise which often accompanies SCA transmission. The demodulated output signal is in the order of 50 millivolts and the frequency response extends to 7 kHz. Alright, and then there's a 10.8 megahertz FSK decoder. Frequency shift keying, I think, but I don't know much about it. This is the NE564 Looks like it's just an integrated circuit does all the work. 24% bandwidth tone decoder. And here is a dual tone decoder. I wonder, oh, okay, it's using a 567 integrated circuit. Fair enough. Resistor and capacitor values chosen for desired frequencies and bandwidth. If C3 is made large so as to delay turn on of the top 567, decoding of sequential F1, F2 tones is possible. Delays. Long time delay generator, door chimes delay, time delay generator, long delay timer using PUT, ultra precise long time delay relay, long duration time delay, simple time delay using 2 SCRs. Okay, there's a long time delay generator, door chimes delay, time delay generator, long delay timer using PUT. The PUT is used as both a timing element and sampling oscillator. A low leakage film capacitor is required for C2 due to the low current supplied to it. Ultra precise long time delay relay. Okay. Over 3 minutes. 3 minutes, it says, is a long time. Long duration time delay, simple time delay using a 555 timer. Detectors. Air motion detector, product detector, low voltage detector, positive peak detector, negative peak detector, precision peak voltage detector with a long memory time, edge detector, ultra low drift peak detector, pulse width discriminator, true RMS detector, fast half wave rectifier, telemetry demodulator, full wave rectifier and averaging filter, double-ended limit detector, half wave rectifier, tone detector, FM tuner with a single tune detector coil, missing pulse detector, high speed peak detector, detector for magnetic transducer, double-ended limit detector, FM demodulator at 5 volts, FM demodulator at 12 volts, precision full wave rectifier, negative peak detector, level detector with hysteresis, window detector, airflow detector, and positive peak detector. Alright. I'm going to go get more coffee. Alright, I'm back. So this is an air motion detector. What do you suppose it means? Sensing circuit detects either steady or fluctuate. Oh, it's airflow. There we go. Okay. The heart of the circuit is a Radio Shack piezo buzzer and the LM324 quad op amp. When a current of air hits the piezo element, a small signal is generated. Ah, there you go. So the piezos are the sensor. How interesting. Product detector. The MC1596/MC1496 makes an excellent SSB product detector. What's an SSB? This product detector has a sensitivity of 3 microvolts and a dynamic range of 90 decibels when operating at an intermediate frequency of 9 megahertz. The detector is broadband for the entire high frequency range. For operation at very low intermediate frequencies down to 50 kilohertz, the 0.1 microfarad capacitors on pins 7 and 8 should be increased to 1 microfarad. Also, the output filter at pin 9 can be tailored to a specific intermediate frequency and audio amplifier input impedance. The emitter resistance between pins 2 and 3 may be increased or decreased to adjust circuit gain, sensitivity, and dynamic range. This circuit may also be used as an AM detector by introducing carrier signal at the carrier input and an AM signal at the SSB input. We don't know what SSB is. We're going to go and look it up. I suppose we will. I'll be back in a sec. Alright, so SSB stands for single sideband, and it's a type of AM signal. So there you go. Some sort of radio sensor. Low voltage detector. Positive peak detector. Negative peak detector. Precision peak voltage detector with long memory time. Edge detector. Ultra low drift peak detector. Pulse width discriminator. True RMS detector. Fast half wave rectifier. Telemetry demodulator. The circuit recovers an FM audio signal that varies from less than 1 kHz to about 10 kHz. Full wave rectifier and averaging filter. Double-ended limit detector. Half wave rectifier. Tone detector. Uses an L144. The detector circuit is made up a 2 amplifier multiple feedback bandpass filter followed by an AC to DC detector section of a Schmidt trigger. The bandpass filter with a Q of greater than 100 passes only 500 Hz inputs, which are in turn rectified by D1 and filtered by R9 and CA. This filtering action, in combination with the trigger level of 5 volts for the Schmidt device, ensures that at least 55 cycles of 500 Hz input must be present before the output will react to a tone input. We've got an FM tuner with a single tuned detector coil. Missing pulse detector. Yeah. The timing cycle is continuously reset by the input pulse train. A change in frequency or a missing pulse allows completion of the timing cycle, which causes a change in the output level. For this application, the time delay should be set to be slightly longer than the normal time between pulses. This graph shows the actual waveform seen in this mode of operation. There you go. High-speed peak detector. Detector for magnetic transducer. FM demodulator at 5 volts. Double-ended limit detector. FM demodulator at 12 volts. Precision full wave rectifier. Negative peak detector. Level detector with hysteresis, positive feedback. Airflow detector. Window detector. Positive peak detector. Chapter 26, digital to analog converters. All right. 14-bit binary digital to analog converter, unipolar, 10-bit digital analog converter, fast voltage output digital analog converter, resistor terminated DAC 0 to negative 5 volt output, 3-digit BCD DAC, 8-bit DAC, high-speed 8-bit DAC, 10-bit 4-quadrant multiplexing digital analog converter, offset binary coding, 8-bit DAC, plus or minus 10 volt, full-scale bipolar DAC, precision 12-bit DAC, 8-bit DAC with output current to voltage conversion, 16-bit binary DAC, plus or minus 10 volt, full-scale unipolar DAC, high-speed voltage output DAC. (14-bit binary DA converter, unipolar. The op-amp characteristics affect DA accuracy and settling time. The following op-amps listed in order of increasing speed are suggested: LM101A, LF156A, and LM11A. There you go. This is a 10-bit DAC. Fast voltage output DAC. Resistor terminated DAC. 3-digit BCD to digital analog converter. There you go. Uh, 8-bit DAC, high-speed 8-bit DAC, 10-bit 4-quadrant multiplexing DAC, offset binary coding. Eight-bit DAC, plus or minus 10 volt full scale bipolar DAC. Precision 12-bit DAC. 8-bit DAC with output current to voltage conversion. 16-bit binary DAC. Plus or minus 10 volt full scale unipolar DAC. High speed voltage output DAC. Dip meters. Dip meter using dual gate IG FET MOSFET. Vari-cap tuned FET dip meter with a 1 kHz modulator. Dip meter using N-channel IG FET MOSFET and separate diode detector. Basic grid dip meter using germanium PNP. Bipolar transistor with separate diode detector. Gate dip meter Gate dip meter covers 1.8 to 150 megahertz. Dip meter using silicon junction FET. Dip meter using dual gauge IG FET. Gate 2 is used to adjust the oscillation level. Dip meter with 1 kHz modulation. I'm not super clear what a dip meter is. Does it mean like a dipstick, like you stick it in and see how high the level is? But I don't know. Dip meter using N-channel and separate diode detector. Plug-in coil. I guess I better look it up. Okay, dip meter is a type of signal detection. It detects the resonant frequency of a circuit, and it dips. The signal dips when the signal resonates. So we don't care about dip meters. We're not doing anything with those. All right, chapter 28, displays. LED brightness control, LED bar dot level meter, 60 decibel dot mode display, bar display with alarm flasher, 12-hour clock with gas discharge displays, precision frequency counter, 1 megahertz maximum, exclamation point display, LED bar peak program meter display for audio, 10 megahertz universal counter, LED brightness control, LED bar dot level meter, 60 decibel dot mode display. Look at all those diodes. Bar display with alarm flasher. 12-hour clock with gas discharge displays. Oh, that's fun. Precision frequency counter. Exclamation point display. LEDs light up as illustrated with the upper lit LED indicating the actual input voltage. The display appears to increase resolution and provides an analog indication of overrange. LED bar peak program meter display for audio. Okay. 10 megahertz universal counter. Fair enough. This is a minimum component complete universal counter. It can use input frequencies up to 10 megahertz at input A and 2 megahertz at input B. If the signal at input A has a very low duty cycle, it may be necessary to use a 74121 monostable multivibrator or similar circuit to stretch the input pulse width to be able to guarantee that it is at least 50 nanoseconds in duration. Dividers. CMOS programmable divide by N counter, frequency divider chain, frequency divider with transient free output, binary divider chain, decade frequency divider. CMOS programmable divide by N counter using the CD4017A. Okay, frequency divider chain. Sawtooth output from each stage is 1/2 frequency of preceding stage. Frequency divider with transient free output. Spikes in the center of a sawtooth wave are limited in this circuit by triggering at gate. Binary divider chain. This circuit uses fewer components than transistor flip-flops. Output at B gives a transient free waveform. Decade frequency divider. Drivers. Driver circuits. I think we're going to scan him as well. I'm going to scan that. Alright, so we've got driver circuits, which I've scanned. We'll have a close look at that in a second. 50 ohm driver, line driver, high speed laser diode driver, capacitive load driver, relay driver, BiFET cable driver, high speed line driver for multiplexers, high impedance meter driver, CRT deflection yoke, CRT yoke driver, solenoid driver, coaxial cable driver, high speed shield / line driver, relay divider with strobe, and direct DC drive interface of a triac. So what have we got here? Driver circuits. We've got a relay driver. We've got a lamp driver. And we've got a speaker driver. Okay, that wasn't as interesting as I thought it would be. CMOS drivers for relays, lamps, speakers, etc. offers extremely low standby power. At VCC equals 15 volts, power dissipation per package is typically 750 nanowatts when the outputs are not drawing current. Thus, the drivers can be sitting out online, a telephone line, for example, drawing essentially zero current until activated. All right, 50 ohm driver. To buffer a test generator to the outside world requires an amplifier with sufficient bandwidth and power handling capability. The circuit is a very simple unity gain buffer. It has a fairly high input impedance, a 50 ohm output impedance, and wide bandwidth, a high slew rate. The circuit is simply two pairs of emitter followers. The base emitter voltages of Q1 and Q2 cancel out, and so do those of Q3 and Q4. The preset is used to zero out any small DC offsets due to mismatching in the transistors. A line driver. High-speed laser diode driver. Capacitive load driver. The circuit employs a 100 ohm isolation resistor, which enables the amplifier to drive capacitive loads exceeding 500 picofarads. The resistor effectively isolates the high frequency feedback from the load and stabilizes the circuit. Low frequency feedback is returned to the amplifier summing junction via the low pass filter formed by the 100 ohm series resistor and the load capacitance CL. Relay driver, BiFET cable driver, relay driver, high speed line driver for multiplexers, high impedance meter driver, CRT yoke driver, CRT deflection yoke driver, solenoid driver. Hello? Sorry, that was a phone call. Just interrupted me. So just continuing on here, finishing up the chapter, we've got a coaxial cable driver, a relay driver with strobe, high-speed shielding line driver, and a direct DC drive interface of a triac. Okay, we've got some fiber optic circuits. Fiber optics half duplex information link, fiber optic receiver, very high sensitivity, low speed, 3 nanowatts. Fiber optic link repeater, fiber optic receiver, high sensitivity, 30 nanowatts. Fiber optic receiver, low sensitivity, 300 nanowatts. Fiber optics half duplex information link. Wow. Fiber optic receiver, very high sensitivity, low speed. Fiber optic link. Fiber optic link repeater. Fiber optic receiver, high sensitivity. Fiber optic receiver, low sensitivity. Field strength meters. Low cost microwave field strength meter. Sensitive field strength meter. Adjustable sensitivity field strength indicator. Field strength meter, 1.5 to 150 megahertz. Simple field strength meter. Untuned field strength meter. Tuned field strength meter. VOM field strength meter. Low cost microwave field strength meter. Sensitive field strength meter. Adjustable sensitivity field strength indicator. Field strength meter, 1.5 to 150 megahertz. Simple field strength meter. Untuned field strength meter. Tuned field strength meter. VOM field strength meter. Filters. Holy cow, there's a lot of filters. 5-pole active filter, digitally tuned low power active filter, 10 kilohertz Sallen key low pass filter, 4th order high pass Butterworth filter, tunable notch filter to suppress hum, 3 amplifier notch filter or elliptical filter building block, selectable bandwidth notch filter, 4.5 megahertz notch filter, high Q notch filter, rejection filter, notch filter using the Micro A4136 as a gyrator, 1 kHz bandpass active filter, bandpass active filter with 60 decibels gain, multiple feedback bandpass filter, biquad RC active bandpass filter, 400 Hz low pass Butterworth active filter, variable bandwidth bandpass active filter, low pass filter, high Q bandpass filter, MFB bandpass filter for multi-channel tone decoder, Sallen key second order low pass filter, 3 amplifier active filter, bandpass state variable filter, universal state variable filter, 500 Hz Sallen key bandpass filter, filter networks, equal component Sallen key low pass filter, biquad filter, second order state variable fitter, 1 kHz Q equals 10, biquad filter, tunable active filter, active RC filter for frequencies up to 150 kHz, pole active low pass filter, Butterworth maximally flat response, speech filter, 30 Hz to 3.3 kHz bandpass, 0.1 Hz to 10 Hz bandpass filter, high pass active filter, second order high pass active filter, high pass filter, high frequency, 160 Hz bandpass filter, multiple feedback bandpass filter, 1 kHz, 20 kHz bandpass active filter, rumble filter using LM387, scratch filter using LM287. 5-pole active filter, digitally tuned low power active filter, 10 kHz Sallen-Key low pass filter, 4th order high pass Butterworth filter, tunable notch filter to suppress hum, 3 amplifier notch filter or elliptic filter building block, selectable bandwidth notch filter, 4.5 MHz notch filter, high Q notch filter, rejection filter, notch filter using the Micro A4136 as a gyrator, 1 kHz bandpass active filter, bandpass active filter with 60 decibels gain, multiple feedback bandpass filter, biquad RC active bandpass filter, 400 Hz low pass Butterworth active filter, variable bandwidth bandpass active filter, low pass filter, high Q bandpass filter, MFB bandpass filter for multi-channel tone decoder, Sallen-Key second order low pass filter, 3 amplifier active filter, bandpass state variable filter, universal state variable filter, 500 Hz Sallen-Key bandpass filter, filter networks, equal component Sallen-Key low pass filter, biquad filter, second order state variable filter, 1 kHz Q equals 10, biquad filter, tunable active filter, active RC filter for frequencies up to 150 kHz, pole active low pass filter, Butterworth maximally flat response, speech filter, 300 Hz to 0.3 kHz bandpass, 0.1 Hz to 10 Hz bandpass filter, high pass active filter, high pass filter high frequency, second order high pass active filter, 160 Hz bandpass filter, multiple feedback bandpass filter, rumble filter using LM387, 20 kHz bandpass active filter, scratch filter using LM387. There was a typo in the that said 287 in the index or the title. Anyway, all right. Flashes and blinkers. Of course, the most important type of circuit. Auto, boat, or barricade flasher, flip-flop flasher, flashlight finder, low-frequency lamp flasher / relay driver, low-cost ring counter for incandescent lamps, dual LED CMOS flasher, automatic safety flasher, neon blinker, transistorized flasher, flasher / light control, neon tube flasher, DC flasher with adjustable on and off time, low voltage flasher, 1 amp lamp flasher, fast blinker, 3 volt flasher, incandescent bulb flasher, flasher for 4 parallel LEDs, LED booster, safe high voltage flasher, alternating flasher, variable flasher, emergency lantern flasher, high efficiency parallel circuit flasher, minimum power flasher. Alright, so we got auto boat or barricade flasher. We've got flip-flop flasher. Flashlight finder. Low frequency lamp flasher / relay driver. Low cost ring counter. Ring counter for incandescent lamps. Dual LED CMOS flasher. Automatic safety flasher. Neon blinker. Transistorized flasher. Flasher / light control. Neon tube flasher. DC flasher with adjustable on and off time. Low voltage flasher. Lamp flasher. 3-volt flasher. Fast blinker. Incandescent bulb flasher. Flasher for 4 parallel LEDs. Safe high voltage flasher. LED booster. Alternating flasher. Variable flasher. High efficiency parallel circuit flasher. Emergency lantern flasher. Minimum power flasher. Frequency measuring circuits. Inexpensive frequency counter / tachometer. Linear frequency meter. Power line frequency meter. Audio frequency meter. Alright. Inexpensive frequency counter / tachometer. The circuit uses the low power ICM 7555 CMOS 555 to generate the gating, store, and reset signals. To provide the gating signal, the timer is configured as an astable multivibrator. The system is calibrated using a 5 meg potentiometer for RA as a course control and a 1 JK, wonder what that means, potentiometer for RB as a finite control. I think it just means 1K. Linear frequency meter for the audio spectrum. Okay. Power line frequency meter. Interesting. Audio frequency meter. Okay. Frequency multipliers. Broadband frequency doubler, 150 to 300 megahertz doubler, low frequency doubler, oscillator with double frequency output. Broadband frequency doubler, 150 to 300 megahertz doubler, low frequency doubler, oscillator with double frequency output. Frequency to voltage converters. DC 10 kilohertz frequency voltage converter. So it's DC to 10 kilohertz frequency / voltage converter. Frequency to voltage converter. Zener regulated frequency to voltage converter. Simple frequency to voltage converter. Frequency voltage conversion, TTL input, frequency to voltage converter with 2-pole Butterworth filter to reduce ripple, precision frequency to voltage converter. This is DC to 10 kilohertz frequency voltage converter. Okay, bunch of op amps and comparators. Frequency to voltage converter, digital frequency meter. Looks like it's all done by an integrated circuit there. Zener regulated frequency to voltage converter, showing you what's going on inside an integrated circuit. Simple frequency to voltage converter using the LM331. Frequency to voltage converter with 2-pole Butterworth filter to reduce ripple. Okay. FV conversions, TTL input. Okay. And precision frequency to voltage converter using the LM331 again. Fair enough. Fuzz circuits. Fuzzbox 1, Fuzzbox 2, Fuzzbox 3, Fuzzbox 4, Fuzzbox 5, and Guitar Fuzz. So it just makes white noise, I guess. The input signal is amplified by transistors. The distorted output is then clipped by the diodes, and a high frequency noise is filtered from the circuit. The 1 meg pot adjusts the intensity of the fuzz from maximum to no fuzz. Alright, Fuzzbox 2. So there's a whole bunch of ways of making noise. None of the components are particularly critical in value or quality, as distortion is the sole object. The transistor could be various ones. The 741 has a maximum gain of 20,000, but the circuit is so designed that the IC's gain is 2,700,000, which then distorts the output. This distortion gives the fuzz effect. The 2 diodes clip the output to drop the level, also lowered by the potential divider. This circuit also sustains the notes due to clipping, giving a totally new sound. Games. Ready, set, go. Electronic dice. Game roller or chase circuit. Toss a coin. Binary box. Electronic coin tosser. Heads or tails. Pot shot. Low cost heads or tails. Who is first? Windicator. Alright, ready, set, go. The game tests a player's reaction time. It is activated by closing switch 1, which starts the tone generator and arms the circuit. The touch plate, labeled play in the diagram, consists of 2 metal strips about 1/16 inch apart. The first player to bridge the gap with his or her fingers turns off the tone and lights the associated LED indicator. The second touch plate, labeled CLR in the diagram, clears the circuit, extinguishing the LED when its gap is bridged by a fingertip. Electronic dice. Alright, fair enough. Game roller or chase circuit. The 555 timer produces a rapid series of pulses whenever switch 1 is open. These pulses are counted in groups of 16 and converted into a binary form by the 7493 and applied to the 74154, a 1 of 16 decoder / D multiplexer, wired so that each of its 16 output lines goes low sequentially and in step with the binary count delivered by the 7493. When the switch is closed, only 1 LED remains on. Only 1 current limiting resistor is used for all the LEDs since only 1 is on at any one time. Okay. Toss a coin binary box. Circuit uses an astable multivibrator to vary the heads or tails condition and a flip-flop to store the condition given by the multivibrator. Consequently, the circuit is wired so that the flip-flop state is changed once for each full duty cycle. The multivibrator goes through to assure an absolutely even 50-50 chance of a heads or tails loss. It'd be fun to make this circuit and verify that claim. Let's scan this circuit. Don't know if we'll look at it, but we'll scan it. I'll be back in a sec, hang on. Alright, I'm back. And we're roughly halfway through the book. So, I was going to scan this. Did I scan this? I'm not sure. Let me check. I did indeed scan this. So, on we go. Electronic coin tosser. Okay. Heads or tails. Pot shot. This is a circuit for a game of the shooting gallery variety. IC2A and B form an astable multivibrator, clocking IC1, which causes LEDs 1 to 8 to flash in turn. LED 5 is the target LED, and the object of the game is to depress PB1 or PBI just as LED 5 comes on. If this is done, the whole display is blanked for a few seconds, signifying a hit. Otherwise, the LED which was lit remains lit. When the push button is released, C2 discharges through R2, taking pin 13 lower gain, and the LEDs will start to flash again. These look like fun, don't they? Yeah, I might come back to these. We might do these. Why not? Games are fun. All right, low cost heads or tails. Okay. Who is first? Here is a circuit for any question and answer party game. The first button push. Oh, okay, I see. Cool. Windicator. 2 TTL ICs and a handful of other components are all that is needed for a circuit that will indicate which of 4 buttons was pressed first. Oh, there we go. They're basically the same. Gas vapor detectors. So we've got gas and smoke detector, ionization chamber smoke detector, ionization chamber smoke detector. Okay. I wouldn't be making my own gas detectors. I think I'll leave that to the professionals. Indicators. 10-step voltage level indicator, beat frequency indicator, 3-step level indicator, indicator and alarm, 5-step voltage level indicator, visible voltage indicator, voltage level detector, 0 center indicator for FM receivers, visual 0 beat indicator, 10-step voltage level indicator. Okay. Beat frequency indicator, 3-step level indicator, indicator and alarm, 5-step voltage level indicator, visible voltage indicator, voltage level detector, 0 center indicator for FM receivers, visual 0 beat indicator. Light emitting diodes connected with reverse polarity provide a visual indication of 0 beat frequency. Each LED is on for only half a cycle of the input. When the input frequency is more than 1 kHz away from the 0 beat frequency, both LEDs appear to be on all the time. As the input frequency comes within about 20 Hz of 0 beat, the LEDs will flicker until 0 beat is reached. Both LEDs glow or flicker until 0 beat is reached when they go out. Infrared circuits. IR type data link, IR remote control transmitter / receiver, compact IR receiver, IR transmitter, remote loudspeaker via IR link, and proximity detector. Okay. Infrared remote control transmitter and receiver. The circuit is designed to operate at 25 kHz. The data stream turns the 2N4401 hard on or off depending on the coded state. This in turn switches the series infrared LEDs on and off. The receiver circuit consists of a 3-stage amplifier with photodiodes arrayed for maximum coverage of the reception area. The range of this setup should be about 10 meters. Here's a compact infrared receiver, an infrared transmitter, and remote loudspeaker via infrared link. Proximity detector. This circuit provides a means of detecting the presence of anything by the reflection of infrared light and provides a direct digital output of object detection. By the use of modulation and high power bursts of infrared at a very low duty cycle, a detection range of over a foot is achieved. Works on the principle of transmitting a beam of modulated infrared light from the emitter diode LED2 and receiving reflections from objects passing in front of the beam with a photodiode detector D1. The circuit consists of an infrared transmitter, photodiode amplifier, and a variable threshold comparator. Instrumentation amplifiers. Okay. Instrumentation amplifier, triple op-amp instrumentation amplifier, differential input instrumentation amplifier with high CMRR, instrumentation amplifier with high CMRR, level shifting isolation amplifier, vertical gain differential input instrumentation amplifier, low signal level high impedance instrumentation amplifier, chopper channel amplifier, battery powered battery amplifier for standard cell, bridge transducer amplifier, instrumentation amplifier, isolation amplifier for medical telemetry, high gain differential instrumentation amplifier, high impedance bridge amplifier, instrumentation amplifier to op-amp design, instrumentation amplifier, differential input instrumentation amplifier, high impedance differential amplifier, high speed instrumentation amplifier, very high impedance instrumentation amplifier, precision FET input instrumentation amplifier, high stability thermocouple amplifier, high stability thermocouple amplifier, high impedance low drift instrumentation amplifier. All right, so we got a whole bunch of amplifiers. There we go. Instrumentation amplifiers, differential amplifiers, are specifically designed to extract and amplify small differential signals from much larger common mode voltages. To serve as building blocks in instrumentation amplifiers, op-amps must have very low offset voltage drift, high gain, and wide bandwidth. The HA4620 and the 5604 is suited for this application. The optional circuitry makes use of the fourth amplifier section as a shield driver, which enhances the AC common mode rejection by nullifying the effects of capacitance to ground mismatch between input conductors. Triple op-amp instrumentation amplifier, differential input instrumentation amplifier with high common mode rejection, instrumentation amplifier with high common mode rejection, level shifting isolation amplifier, variable gain differential input instrumentation amplifier, instrumentation amplifier, low signal level high impedance instrumentation amplifier, chopper channel amplifier, battery powered buffer amplifier for standard cell, bridge transducer amplifier, instrumentation amplifier, isolation amplifier for medical telemetry, high gain differential instrumentation amplifier, high impedance bridge amplifier, instrumentation amplifier to op-amp design, high impedance differential amp, instrumentation amplifier, high speed instrumentation amplifier, differential input instrumentation amplifier, very high impedance instrumentation amplifier, precision FET input instrumentation amplifier, high stability thermocouple amplifier, high stability thermocouple amplifier, high impedance low drift instrumentation amplifier. Light activated circuits. Pulse generation by interrupting a light beam, optical communication system, 4-quadrant photoconductive detector amplifier, precision photodiode comparator, automatic nightlight, receiver for 50 kHz FM optional transmitter, photodiode amplifier, optical Schmidt trigger, adjustable light detection switch, photocell memory switch for AC power control, optical transmitter, light interruption detector, optical receiver, light isolated power relay circuit, precision photodiode level detector, light beam operated on-off relay, logarithmic light sensor, FM, PRM, optical transmitter. When it says optional here, I wonder if that meant to be optical. I'm not sure. We'll see when we get to it maybe. Light level sensor. Pulse generation by interrupting a light beam. Optical communication system. That'd be fun to make actually. For Actually, just give me a second. All right, I'm back, and I just got myself a pen and paper. Today is, what's the date today? 19th. And let's say Encyclopedia, and let's say page 358. So this is just circuits that I think it might be fun to make. So just notes for John. And on we go. So what have we got next? 4-quadrant photoconductive detector amplifier. Okay. Precision photodiode comparator. Automatic nightlight. Receiver for 50 kilohertz from optical transmitter. Yeah, I think that was the one they got wrong. They thought it said optional. Photodiode amplifier. Optical Schmidt trigger. Adjustable light detection switch. Photocell memory switch for AC power control. Optical transmitter. Light interruption detector. Optical receiver. Light isolated solid state power relay circuit. Precision photodiode level detector. Light beam operated on-off relay. Logarithmic light sensor. FM PRM optical transmitter. Light level sensor. Okay, now we're up to light controls. Light dimmers, remote control for lamp or appliance. High power control for sensitive contacts. Complementary lighting control. Flood lamp power control. Hysteresis free phase control circuit. Low cost lamp dimmer. 0-point switch. 800 watt triac light dimmer. Full wave SCR control. 860 watt limited range low cost precision light control. 800 watt soft start light dimmer. Low loss brightness control. Half wave AC phase controlled circuit. Emergency light. Neon lamp driver. Complementary AC power switching. Battery lantern circuit. Shift register. Oh, that's interesting. Light level controller and 2.2 watt incandescent 2.2 watt incandescent lamp driver. So here's a light dimmer. Remote control for lamp or appliance. That's a wired remote control. High power control for sensitive contacts. Complementary lighting control. Flood lamp power control. Hysteresis free phase control circuit. Low cost lamp dimmer. 0-point switch. 800 watt triac light dimmer. Full wave SCR control. 860 watt limited range low cost precision light control. 800 watt soft start light dimmer. Low loss brightness control. Half wave AC phase controlled circuit. Emergency light. Neon lamp driver. Complementary AC power switching. Battery lantern circuit. Shift register. I wonder what shift register is doing in there. Light level controller. And 2.2 watt incandescent lamp driver. Let's read about the shift register. The shift pulse amplitude is less than 15 volts. If a stage is off, the shift pulse will not be coupled to the next stage. If it's on, the diode will conduct and trigger the next stage. Just prior to the shift pulse, the anode supply is interrupted to turn off all stages. The stored capacitor charge determines which stages will be triggered. Interesting. Light measuring circuits. Linear light meter circuit, logarithmic light meter circuit, light meter, light meter, light meter, Precision photodiode comparator. This is a linear light meter circuit. This is a logarithmic light meter circuit. This is a light meter with a bunch of LEDs. Another light meter. And this is a precision photodiode comparator. Alright, liquid level detectors. Level sensor for cryogenic fluids. Fluid level control, high level warning device, liquid level control, liquid level detector latching, water level alarm, water level sensing control unit, flood alarm, liquid level detector, low level warning with audio output. Level sensor for cryogenic fluids, fluid level controller, high level warning device, liquid level control, liquid level detector, water level alarm, water level sensing control unit, control circuit, flood alarm, liquid level detector, low level warning with audio output. Logic circuits. Light activated logic circuits, programmable gate, negative to positive supply logic level shifter, OR gate, large fan-in AND gate, RS flip-flop, AND gate. Alright, so there's a bunch of logic circuits for you. You would have thought they'd have more, but they've got a couple. Alright, so we've got light activated logic circuits. AND, OR, flip-flop. These circuits illustrate some of the common logic functions that can be implemented. Programmable gate. This gate converts an AND gate or an OR gate by applying a logic 1 on the function input. The logic design uses 8 2-input NAND gates. The number of gates may be reduced by replacing the 5 NAND gates enclosed by the dotted line with a 2-input exclusive OR, such as the TTL7486. Negative to positive supply logic level shifter, OR gate, AND gate, OR gate, RS flip-flop, large fan-in gate, AND gate. Measuring circuits. FET curve tracer, digital weight scale, low-cost pH meter, pH probe amplifier / temperature compensator, capacitance meter, Zener tester, transistor sorter / tester, go-no-go diode tester, peak level indicator, sound level monitor, linear variable differential transformer, LVDT, driver demodulated, linear variable differential transformer, LVDT measuring gauge, vibration meter, sensitive RF voltmeter, minimum component tachometer, phase meter, precision calibrated standard, Zener diode checker. Alright, this is a FET curve tracer. This circuit displays drain current versus gate voltage for both P and N channel JFETs at a constant drain voltage. Digital weight scale. Okay. Low cost pH meter. pH probe amplifier / temperature compensator. Capacitance meter. Zener tester. Transistor sorter / tester. It's for BJTs. Go-no-go diode tester. Diode tester. Peak level indicator. Sound level monitor. Linear variable differential transformer, LVDT, driver demodulator. Linear variable differential transformer, LVDT, measuring gauge. vibration meter, sensitive RF voltmeter, minimum component tachometer, phase meter. That's interesting. Precision calibration standard. Zener diode checker. Metal detectors. Micro power metal detector. Low parts treasure locator. Micro power metal detector. Pretty simple. Low parts treasure locator. All right. Metronomes. Accentuated beat metronome. Sight and sound metronome. Metronome. Okay, this is an accentuated beat metronome. I'm not even sure what that is. Sight and sound metronome. Okay, and here's another metronome. This compact metronome will run for years on a single 9-volt transistor battery. Miscellaneous circuits. Intercom, musical organ, laser diode pulsar, capacitance multiplier, simulated inductor, active inductor, positive input, negative output charge pump, shift register driver, tape recorder, negative edge differentiator, stylus organ, positive edge differentiator, 4-channel data acquisition system, triac trigger, precision rectifiers, voltage control resistor, fast inverter circuit, inverse scaler, 5-volt square wave calibrator, low drift integrator and low leakage guarded reset, differentiator with high common mode noise rejection, digital transmission oscillator. There we go, there's an intercom. Pretty simple. Musical organ using the SN76477 integrated circuit. Cool. Laser diode pulsar. I'm actually going to come back to this one. I'm interested in that. So let's make a note. Page 415. Laser diode pulsar. Capacitance multiplier. Simulated inductor. Active inductor. Positive input, negative output charge pump. Shift register driver. Tape recorder. Negative edge differentiator. Stylus organ. Positive edge differentiator. I might make a note of that one as well. 420. 4-channel data acquisition system. Triac trigger. Precision rectifiers. Fast inverter circuit. Voltage control resistor. Inverse scaler. Square wave calibrator. Low drift integrator and low leakage guarded reset. Differentiator with high common mode noise rejection. Digital transmission oscillator. Mixers and multiplexers. The sources of the following differential mux/demux system, 8-channel mux/demux system, doubly balanced mixer, common source mixer, 100 megahertz mixer, multiplexer/mixer, wideband differential multiplexer. So this is differential mux demux system. All right. It uses a bunch of integrated circuits. This is an 8-channel mux demux system. Okay. This is a doubly balanced mixer, broadband inputs, 9 MHz tuned output, 100 MHz mixer, common source mixer, multiplexer / mixer, wideband differential multiplexer. Modulation monitors. Modulation monitor, visual modulation indicator, and CB modulation monitor. Modulation monitor, visual modulation indicator. Indicator lamp brightness varies in step with modulated RF signal. CB modulation. Connect this circuit to a transceiver with a coaxial T connector in the transmission line. Key the transmitter. Set S1 to cal and adjust R2 for full scale reading. Return S1 to mod. The meter will read percentage modulation with 10% accuracy. Modulators. TV modulator, pulse position modulator, pulse width modulator, RF modulator, linear pulse width modulator, balanced modulator, video modulator, pulse width modulator, AM modulator, TV modulator using a Motorola MC1374, pulse width modulator, VHF modulator. This is a TV modulator. The FM oscillator / modulator is a voltage-controlled oscillator which exhibits a nearly linear output frequency versus input voltage characteristics for a wide deviation. It provides a good FM source with a few inexpensive external parts. It has a frequency range of 1.4 to 14 MHz and can typically produce a plus or minus 25 kHz modulated 4.5 MHz signal with about 0.6% total harmonic distortion. TV modulator, pulse position modulator, pulse width modulator, RF modulator, linear pulse width modulator, video modulator, balance modulator, plus 12 volt VDC single supply modulator, pulse width modulator, AM modulator. TV modulator using a Motorola MC1374, pulse width modulator, VHF modulator. Moisture and rain detectors. Rain alarm, moisture detector, automatic plant waterer, rain alarm / doorbell. Alright, there's the rain alarm, moisture detector, automatic plant waterer, rain alarm / doorbell. Motor controls. Alright, motor speed control, plug-in speed control for tools or appliances, motor speed control with feedback, direction, and speed control for series wound motors, high torque motor speed control, constant current motor drive circuit, AC motor power brake, universal motor speed control with load dependent feedback, DC motor speed direction control circuit, servo motor amplifier, motor speed control, model train speed control, induction motor control, DC motor speed control, universal motor control with built-in self-timer, speed control for model trains or cars, direction and speed control for shunt wound motors, two-phase motor drive, DC servo amplifier, universal motor speed control, power tool torque control, AC servo amplifier, bridge type. Alright, this is motor speed control. This circuit is a regulating series DC motor speed control using the LM3524 for the control and drive for the motor and the LM2907 as a speed sensor for the feedback network. Right. Plug-in speed control for tools or appliances. Motor speed control with feedback. Direction and speed control for series wound motors. High torque motor speed control. Motor speed control. Constant current motor drive circuit. AC motor brake. Universal motor speed control with load dependent feedback. DC motor speed direction control circuit. Servo motor amplifier. Motor speed control. Model train speed control. Induction motor control. DC motor speed control. Universal motor control with built-in self-timer. Speed control for model trains or cars. Direction and speed control for shunt wound motors. Two-phase motor drive. DC servo amplifier. Universal motor speed control. Power tool torque control. AC servo amplifier bridge type. Multivibrators. Monostable circuit, astable multivibrator, astable oscillator, digitally controlled astable multivibrator, dual astable multivibrator, UJT monostable, monostable multivibrator with input lockout, TTL monostable, monostable circuit, one-shot multivibrator, monostable multivibrator, bistable multivibrator, 100 kHz free running multivibrator. Monostable circuit, astable multivibrator. Oh, they're just using 555. Fair enough. Astable oscillator, digitally controlled astable multivibrator, dual astable multivibrator, UJT monostable. Monostable multivibrator with input lockout, TTL monostable, monostable circuit, one-shot multivibrator, bistable multivibrator, monostable multivibrator, 100 kHz free running multivibrator. Noise generators. Audio noise generator, pink noise generator, wideband noise generator circuit. Audio noise generator, pink noise generator, wideband noise generator circuit. I'm just going to look up pink noise. All right, so pink noise, the amplitude falls off with frequency. So there you go. The higher the frequency, the lower the amplitude. So it sounds different to white noise. All right, noise generator, wideband noise generator circuit, oscilloscope circuits. Oscilloscope converter provides 4-channel displays, add-on triggered sweep, 10.7 MHz sweep generator, drawing circles on a scope, transmitter oscilloscope coupler for CB signals, oscilloscope monitor, beam splitter for oscilloscope. All right, oscilloscope converter provides 4-channel displays. Add-on triggered sweep, sweep generator, drawing circles on a scope, transmitter. This is all CRT stuff. Beam splitter. Phase, sequence, and phase shift circuits. Phase sequence indicator, single transistor phase shifter, 0 to 180 degrees phase shifter, phase shift circuits, precision phase splitter, 0 to 360 phase shifter. Phase sequence indicator, single transistor phase shifter, 0 to 180 degrees phase shifter, precision phase splitter, phase shift circuits, 0 to 360 degrees phase shifter. Photography related circuits, automatic contrast meter, darkroom timer, photo stop action, sound light flash trigger, sound activated strobe trip, flash slave driver, remote flash trigger, flash exposure meter, shutter tester, photographic timer. Okay, this is automatic contrast meter. Okay, it's got a sort of bar graph outline. Darkroom timer. The darkroom timer controller uses a few external components, a display, a digit driver, keyboard, and output switching devices. A 4-digit common cathode LED display is desirable for darkroom environments. The time base is provided by shaping up the 50 or 60 Hz AC line. I have no idea what this does. Darkroom timer. Oh, just a timer for using in a darkroom. Huh. All right. Photo stop action. Sound light flash trigger. Sound activated strobe trip. Flash slave driver. Remote flash trigger. Flash exposure meter. Shutter tester. Photographic timer. Power measuring circuits. Extended range VU meter. Dot mode. Audio power meter. Power meter 1 kilowatt full scale. 60 megahertz power gain test circuit. All right, that was the extended range VU meter. This is an audio power meter, power meter, 1 kilowatt full scale, 60 megahertz power gain test circuit. Power supplies fixed. All right, we've got a switching regulator operating at 200 kilohertz, 5 volt, 0.5 amp power supply, 3 watt switching regulator application circuit, regulated split supplies from a single supply, switching step down regulator, single ended regulator, plus or minus 50 volt push pull switch mode converter, 5 volt, 0.5 amp buck converter, plus or minus 50 volt feed forward switch mode converter, traveler's shaver adapter, 100V RMS voltage regulator, transistor increases Zener rating, dual polarity power supply, 5 volt 6 amp 25 kilohertz switching regulator with separate ultra stable reference, mobile voltage regulator, negative switching regulator, positive switching regulator, positive floating regulator, negative floating regulator, negative voltage regulator, minus 15 volt negative regulator, slow turn on 15 volt regulator, high stability 10 volt regulator, 5 volt 1 amp switching regulator, 15 volt 1 amp regulator with remote sense, low ripple power supply, 5 volt 10 amp regulator, 5 volt 3 amp regulator, 100 volt 10.25 amp switch mode converter, voltage regulator, low voltage regulators with short circuit protection, high stability 1 amp regulator, 100 volt 0.25 amp switch mode converter. Switching regulator operating at 200 kilohertz. 5 volt half amp power supply, 3 watt switching regulator application circuit, regulated split power supplies from a single supply, switching step down regulator, single ended regulator, plus or minus 50 volt push pull switch mode converter, 5 volt half amp buck converter, plus or minus 50 volt feed forward switch mode converter, traveler's shaver adapter, 100 volt RMS voltage regulator. Transistor increases Zener rating. Dual polarity power supply. Actually, I'm going to read about that. The simple Zener shunt in A may not handle sufficient current if the Zener available is of low wattage. A power transistor will do most of the work for the Zener as shown in B. Once the Zener starts conducting, a bias voltage develops across the resistor. Turning on the transistor, the output voltage is 0.7 volts greater than the Zener voltage. There you go. Dual polarity power supply, 5 volt 6 amp 25 kilohertz switching regulator with separate ultra stable reference. I'm going to make a note. I'm going to scan this particular thing. I'll be back. All right, I'm back. I just scanned this one because I want to remember this. This is a pattern I want to know about. Dual polarity power supply. 5 volt 6 amp 25 kilohertz switching regulator with separate ultra stable reference. Mobile voltage regulator, negative switching regulator, positive floating regulator, positive switching regulator, negative floating regulator, negative voltage regulator, high stability 10 volt regulator, minus 15 volt negative regulator, 5 volt 1 amp switching regulator, slow turn on 15 volt regulator, 15 volt 1 amp regulator with remote sense. Low ripple power supply, 5 volt 10 amp regulator, 5 volt 3 amp regulator, 100 volt 10.25 amp switch mode converter, voltage regulator, low voltage regulator with short circuit protection, high stability 1 amp regulator, 100 volt quarter amp switch mode converter. Power supplies, variable, dual output bench power supply with adjustable current limit and output voltage, adjustable output regulator, 10 milliamp negative voltage from a positive source, regulated voltage divider, variable Zener diode, 12 volt to 9, 7.5 or 6 volt converter, 5 amp constant voltage constant current regulator, power pack for battery powered calculators, radios or cassette players, precision high voltage regulator, remote shutdown regulator with current limiting, 0 to 22 volt regulator, 0 to 30 volt regulator, 10 amp regulator, adjustable regulator 0 to 10 volt at 3 amps, high voltage regulator, low voltage regulator, simple split power supply, adjustable output regulator, multiple output switching regulator for use with MPUs, 6 amp variable output switching regulator. All right, so we've got dual output bench power supply, power supply with adjustable current limit and output voltage, adjustable output regulator, RF probe for VTVM, regulated voltage divider, variable Zener diode, 12 volt to 9, 7.5 or 6 volt converter, a constant voltage current, a constant voltage or constant current regulator, power pack for battery powered calculators, radios or cassette players, precision high voltage regulator, remote shutdown regulator with current limiting, 0 to 30 volt regulator, 0 to 22 volt regulator, a 10 amp regulator, adjustable current 0 to 10 volt at 3 amp, high voltage regulator, low voltage regulator, simple split power supply, adjustable output regulator, multiple output switching regulator for use with MPUs. I don't know what an MPU is. MPU, not sure. a variable output switching regulator, power supply protection circuits, electronic crowbar for AC or DC lines, power protection circuit, simple crowbar, overvoltage protection with automatic reset, overvoltage protection for logic, fast acting power supply protection, 5-volt crowbar, electronic crowbar for AC or DC lines. For positive protection of electrical or electronic equipment, use this against excessive supply voltage. Due to improper switching, wiring, short circuits, or failure of regulators, an electronic crowbar circuit can quickly place a short circuit across the power lines, thereby dropping the voltage across the protected device to near zero and blowing a fuse. The TRIAC and SBS are both bilateral devices. The circuit is equally useful on AC or DC supply lines. With the values shown for R1, R2, and R3, the crowbar operating point can be adjusted over the range of 60 to 120 volts DC or 42 to 84 volts AC. The resistor values can be changed to cover a different range of supply voltages. The voltage rating of the triac must be greater than the highest operating point as set by R2. I1 is a low power incandescent lamp with a voltage rating equal to the supply voltage. It may be used to check the set point and operation of the unit by opening the test switch and adjusting the input or set point to fire the SBS. An alarm unit such as the Mallory Sonar Alert may be connected across the fuse to provide an audible indication of crowbar action. This circuit may not act on short, infrequent power line transients. Power protection circuit, simple crowbar. They call it a crowbar because it's a short circuit, like when you put a crowbar across the terminals of your car battery, which you don't want to do. Overvoltage protection with automatic reset, overvoltage protection for logic. Okay. Fast acting power supply protection, 5-volt crowbar. Probes. Logic probe yields 3 discrete states. Signal injector / tracer, injector / tracer, CMOS logic probe, RF probe for VOM, 100K mega ohm DC probe, audible TTL probe, logic test probe with memory, logic probe, simple logic probe, audio RF signal tracer probe, TTL logic tester. Logic probe yields 3 discrete states. The circuit uses a dual LED. When power is applied to the probe through the power leads, the input is touched to a low level or ground. Q1 is cut off. This will cause Q2 to conduct since the base is positive with respect to the emitter. With Q1 cut off and Q2 conducting, the green diode of the dual LED will be forward biased, yielding a green output. Touching the probe tip to a high level will cause Q1 and Q2 to complement, and the red diode will forward biased, yielding a red output from the LED. An alternating signal will cause alternating conduction of the red and green diodes and will yield an indication approximately amber. In this manner, both static and dynamic signals can be traced with the logic probe. I'm gonna make a note about that. That's page 520. Signal injector / tracer. Okay. Injector tracer. Okay. CMOS logic probe. Okay. RF probe for voltmeter. 100K mega ohm DC probe. Audible TTL probe. Logic probe. Logic test probe with memory. Logic probe. simple logic probe, audio RF signal tracer probe, TTL logic tester, pulse generators, pulse generator, single op-amp oscillator, programmable pulse generator, unijunction transistor pulse generators, pulse generator, free running oscillator, pulse generator with 25% duty cycle, pulse generator, 555 timer oscillator, versatile two-phase pulse generator, single op-amp oscillator, programmable pulse generator, unijunction transistor pulse generators, pulse generator, free running oscillator, pulse generator with 25% duty cycle, 555 timer oscillator, versatile two-phase pulse generator, radiation detectors, dosage rate meter, wideband radiation monitor, gamma ray pulse integrator, sensitive Geiger counter, nuclear particle detector. All right, this is a dosage rate meter, wideband radiation monitor, gamma ray pulse integrator, sensitive Geiger counter, nuclear particle detector. Ramp generators, staircase generator, linear voltage ramp generator, precision ramp generator with variable reset level, staircase generator, linear voltage ramp generator, precision ramp generator with variable reset level. Receivers, clock radio, AM, FM clock radio, AM radio, FM stereo demodulation system, analog receiver, FM radio, simple LF converter, CMOS line receiver, squelch circuit for AM or FM, VLF converter. All right. Well, here's a clock radio, AM, FM clock radio, AM radio, FM stereo demodulation system, analog receiver, low temperature drift, FM radio, simple LF converter, CMOS line receiver, squelch circuit for AM or FM, VLF converter. This converter uses a low-pass filter instead of the usual tuned circuit, so that the only tuning required is with the receiver. The dual-gate MOSFET and FET used in the mixer and oscillator aren't critical. Any crystal having a frequency compatible with the receiver tuning range may be used. Resistance and continuity measuring circuits. Linear scale ohmmeter, low parts count ratiometric resistance measurement, audio continuity tester, low resistance continuity tester, buzzbox continuity and coil checker, linear scale ohmmeter, bridge circuit. Linear scale ohmmeter, low parts count radiometric resistance measurement, audio continuity tester, low resistance continuity tester, buzzbox continuity and coil checker, linear scale ohmmeter, bridge circuit, for measurement of resistances from about 5 ohms down to about 1/10 of an ohm. There you go. RF amplifiers. 100 watt PEP, 450 megahertz push-pull linear amplifier, 140 watt PEP amateur radio limiter amplifier, 230 megahertz, 160 watt PEP broadband linear amplifier, 80 watt PEP broadband linear amplifier, single device, 80 watt 50 ohm VHF amplifier, 600 watt RF power amplifier, wideband UHF amplifier with high performance FETs, 10 MHz coaxial line driver, VHF preamplifier, shortwave FET booster, low noise 30 MHz preamplifier, low noise broadband amplifier, 2 meter 10 watt power amplifier, 2-stage 60 MHz IF amplifier, 28 volt wideband amplifier, 200 MHz cascode amplifier, 135 to 175 MHz amplifier, 200 MHz cascode amplifier, 100 MHz and 400 MHz neutralized common source amplifier, ultra high frequency amplifier, UHF amplifier inverting gain of 2 with lag lead compensation, transistorized Q multiplier for use with IFs in the 1.4 megahertz range, 60 megahertz amplifier, 30 megahertz amplifier, 2 meter amplifier, 5 watt output, 80 megahertz cascode amplifier, 200 megahertz neutralized common source amplifier, 450 megahertz common source amplifier. Wow. I'm trying to avoid RF stuff. I don't want to fall into that rabbit hole. 100 watt PEP, blah blah blah. 140 watt PEP, amateur radio linear amplifier. Okay, amplifiers all over the place. So let's just flip through all of these. All right, we're up to RF oscillators. 500 megahertz oscillator, low distortion oscillator, 400 megahertz oscillator, 2 megahertz oscillator, 1 megahertz oscillator, Hartley oscillator, Colpitts oscillator, RF oscillator. All right, 500 megahertz oscillator, low distortion oscillator, 400 megahertz oscillator, 1 megahertz oscillator, 2 megahertz oscillator, Hartley oscillator, Colpitts oscillator, RF oscillator. Remote control circuits, radio control receiver decoder, carrier operated relay, remote control servo system, tone actuated relay, radio control motor speed controller, remote on off switch, automatic turn off for TV set, radio control receiver and decoder, carrier operated relay, remote control servo system, tone actuated relay, radio control motor speed controller, remote on off switch, automatic turn off for TV set, safety and security circuits, Tarry light, ground tester, ground fault interrupter, single source emergency lighting system, power failure alarm, AC hot wire probe, power failure detector, power failure alarm, electronic combination lock. Tarry light. The push button and potentiometer initiate a time delay that turns a light on, then automatically turns it off again after a predetermined time. There we go. Ground tester, ground fault interrupter, 120 Hz neutral transformer approach, single source emergency lighting system, power failure alarm, AC hot wire probe, power failure detector, power failure alarm, electronic combination lock, sample and hold circuits, peak detect and hold, low drift sample and hold, JFET sample and hold, high speed sample and hold amplifier, high speed sample and hold, high speed sample and hold with offset adjustment, differential hold, times 1000 sample and hold, high accuracy sample and hold, high speed sample and hold. All right, so there's a peak detect and hold, low drift sample and hold, JFET sample and hold, high speed sample and hold, high speed sample and hold, high speed sample and hold with offset adjustment, differential hold, times 1000 sample and hold, high accuracy sample and hold, high speed sample and hold. Schmidt triggers. Schmidt trigger without hysteresis. Schmidt trigger with programmable hysteresis. Schmidt trigger, zero crossing detector with hysteresis, and a Schmidt trigger. Alright, there's a Schmidt trigger without hysteresis. Here's a Schmidt trigger with programmable hysteresis. The Schmidt trigger, zero crossing detector with hysteresis. Schmidt trigger. Alright. Smoke and flame detectors. Photoelectric smoke detector, non-latching, 1.9 volt battery operated ionization type smoke detector. Line operated photoelectric smoke alarm using light sensitive resistor, includes detection of open circuited LED. Photoelectric smoke detector, non-latching. 1.9 volt battery operated ionization type smoke detector, and line operated photoelectric smoke alarm using light sensitive resistor, includes detection of open circuited LED. Sound effect circuits. Voltage controlled amplifier or tremolo circuit, music synthesizer, pre-programmed single chip microcontroller for musical organ. Musical envelope. I'm just going to make a note of this whole chapter. 597. 597. Musical envelope generator and modulator, stereo reverb system, tone burst generator, musical chime generator, sound effect generator, programmable bird sounds, stereo reverb enhancement system, siren, space war, phaser gun, 4-channel synthesizer, voltage controlled amplifier or tremolo circuit, music synthesizer. 3 modes of operation are available in the music synthesizer mode: play a note, play one of 4 stored tunes, or record a tune for subsequent replay. Fun. Pre-programmed single chip microcontroller for musical organ. 25 musical keys and 25 LEDs are provided to denote F to F. Is it F flat? I don't know. It's not F sharp. With half notes in between. Yeah, I don't know anything about music. Musical envelope generator and modulator, stereo reverb system, 4-channel synthesizer, tone burst generator, musical chime generator, sound effect generator, programmable bird sounds, stereo reverb enhancement system, and a siren, space war, phaser gun. Sound, audio operated circuits, voice activated switch and amplifier, audio operated relay, sound modulated light source, audio controlled lamp, sound activated relay, sound operated two-way switch, voice activated switch and amplifier, audio operated relay, sound modulated light source, audio controlled lamp. Audio controlled lamp. This is an on-off control with isolated low voltage input, since the switching action is very rapid compared with the response time of the lamp and the response of the eye. The effect produced with audio input is similar to a proportional control circuit. If the input signal to SCR consists of phase controlled pulses, full wave control of the lamp load is obtained. Sound activated relay, sound operated two-way switch. Squarewave oscillators. RC oscillator, 1 kHz square wave oscillator, TTL oscillator, square wave oscillator, adjustable TTL clock, square wave oscillator, oscillator/clock generator, CMOS oscillator, free running square wave oscillator, precision squares, square wave oscillator, half hertz square wave oscillator, simple triangle/square wave oscillator, square wave oscillator. RC oscillator, 1 kHz square wave oscillator, TTL oscillator, square wave oscillator, adjustable TTL clock, maintains 50% duty cycle, square wave oscillator, oscillator clock generator, CMOS oscillator, free running square wave oscillator, precision squarer, square wave oscillator, half hertz square wave oscillator, simple triangle square wave oscillator, square wave oscillator, stereo balance circuits, stereo balance meter, stereo balancer, stereo balance meter. Okay, here's a stereo balance meter, stereo balancer, stereo balance meter. Switches. DTL, TTL controlled buffered analog switch, high toggle rate, high frequency analog switch, differential analog switch, high frequency switch, 2-channel switch, 10 amp, 25 volt DC solid state relays. DTL, TTL controlled buffered analog switch, high toggle rate, high frequency analog switch, differential analog switch, high frequency switch, triac 0 voltage switching, 2-channel switch, 10 amp, 25 volt DC solid state relays. Telephone related circuits. Oh, this is an anachronism. Portable tone generator, telephone status monitor using an opto isolator, telephone tone ringer, FCC approved telephone tone ringer, telephone or extension tone ringer, telephone line monitor, tone dial generator, tone dial encoder, tone dial sequence decoder, remote ring extender switch, tone dial decoder, telephone relay, telephone controlled tape starter, TCTS, telephone line powered repertory dialer, telephone off hook indicator, telephone handset tone dial encoder, low line loading ring detector, phone auto answer and ring indicator, auto patch telephone phone line interface, telephone ringer uses piezoelectric device, electronic phone bell. Portable tone generator. There we go. It's DTMF, dual tone, multiple frequency. Telephone status monitor using an opto oscillator. Telephone tone ringer. FCC approved telephone tone ringer. Telephone or extension tone ringer. Telephone line monitor. Tone dial generator. Tone dial encoder. Tone dial sequence decoder. Oh, that's interesting. Remote ring extender switch. Tone dial decoder. Telephone relay. Telephone controlled tape starter. Telephone line powered repertory dialer. Repertory dialer phone has a library of 15 frequently used numbers. Oh, I see. Telephone off-hook indicator, telephone handset tone dial encoder, low line loading ring detector, phone auto answer and ring indicator, auto patch telephone line interface. Telephone ringer uses piezoelectric device, electronic phone bell. Temperature controls. Boiler control, heater control, 2-wire remote AC electronic thermostat, 3-wire electronic thermostat, temperature sensitive heater control, temperature controller, single set point temperature controller, temperature controller, temperature control, temperature controller, temperature controller, portable calibrator. All right. This is a boiler control, heater control, 2-wire remote AC electronic thermostat, gas or oil furnace control. 3-wire electronic thermostat, temperature sensitive heater control. Temperature controller, single set point temperature controller. Temperature controller, temperature control, temperature controller, temperature controller. Portable calibrator. '87 temperature sensors. We've got heaps of them. linear temperature to frequency transconducer, temperature meter, 4-channel temperature sensor, integrated circuit temperature sensor, precision temperature transducer with remote sensor, centigrade calibrated thermocouple thermometer, micro P controlled digital thermometer, isolated temperature sensor, digital thermometer, variable offset thermometer, differential thermometer, basic digital thermometer, Kelvin scale, basic digital thermometer, Kelvin scale with 0 adjust, thermocouple amplifier, optical pyrometer, remote temperature sensing, simple differential temperature sensor, centigrade thermometer, meter thermometer with trimmed output, Kelvin thermometer with ground referred output, low power thermometer, 0 degrees Fahrenheit to 50 degrees Fahrenheit thermometer, temperature to frequency converter, 0 degrees Celsius to 100 degrees Celsius thermometer, ground referred Fahrenheit thermometer, ground referred centigrade thermometer, ground referred centigrade thermometer, temperature sensor, positive temperature coefficient resistor temperature sensor, basic digital thermometer, Fahrenheit thermometer. Wow. All right, so that's linear temperature to frequency transconducer, temperature meter, 4-channel temperature sensor, integrated circuit temperature sensor, precision temperature transducer with remote sensor, centigrade calibrated thermocouple thermometer, micro P controlled digital thermometer, isolated temperature sensor, digital thermometer, variable offset thermometer, differential thermometer, basic digital thermometer Kelvin scale, basic digital thermometer Kelvin scale with 0 adjust. This circuit allows 0 adjustment as well as slope adjustment. The ICL 8069 brings the input within the common mode range, while the 5K pots trim any offset at 218 degrees Kelvin or minus 55 degrees Celsius and set the scale factor. Thermocouple amplifier, remote temperature sensing, optical pyrometer, simple differential temperature sensor, Kelvin thermometer with ground referred output, centigrade thermometer, low power thermometer, meter thermometer with trimmed output, 0 degrees Fahrenheit to 50 degrees Fahrenheit thermometer, temperature to frequency converter, 0 degrees Celsius to 100 degrees Celsius thermometer, ground referred Fahrenheit thermometer, ground referred centigrade thermometer, temperature sensor, ground referred centigrade thermometer, positive temperature sensor coefficient resistor, basic digital thermometer, Celsius and Fahrenheit scales, Fahrenheit thermometer, timers, thumb wheel programmable interval timer, sequential UJT timer circuit, time delay relay, 0.1 to 90 second timer, sequential timing, solid state timer for industrial applications, precision solid state time delay circuit, electronic egg timer, on-off controller, timing circuit, simple timer, long interval RC timer, 741 timer, washer timer, simple time delay. Thumb wheel programmable interval timer. It's a WD55. I wonder, don't know what that is. Sequential UJT timer, time delayed relay for patio light, garage light, enlarger potentiometer, etc. 0.1 to 90 second timer, sequential timing, solid state timer for industrial applications, precision solid state time delay circuit, electronic egg timer, on-off controller. This is the WD55 again. I don't know what that integrated circuit is. Timing circuit, simple timer, long interval RC timer, 741 timer, washer timer, simple time delay, tone controls, stereo phonograph amplifier with bass control, bass tone control, equalizer, 3-channel tone control, IC preamplifier with tone control, amplifier with bass boost, active bass and treble tone control with buffer, passive bass and treble tone control, Baxandall tone control circuit, high quality tone control, microphone preamplifier with tone control, hi-fi tone control circuit, 3-band active tone control circuit, stereo phonograph amplifier with bass tone control, equalizer, 3-channel tone control, IC preamplifier with tone control, amplifier with bass boost, active bass and treble tone control with buffer, passive bass and treble tone control, Baxandall tone control circuit, high quality tone control, microphone preamplifier with tone control, hi-fi tone control circuit, high Z input, 3-band active tone control circuit, transmitters, wireless AM microphone, 27 megahertz and 49 megahertz RF oscillator and transmitter, 1 to 2 megahertz broadcaster transmitter, 1 tube 10 watt continuous wave transmitter, simple FM transmitter, wireless AM microphone, (27 megahertz and 49 megahertz RF oscillator / transmitter), 1 to 2 megahertz broadcast transmitter, 1 tube 10 watt continuous wave transmitter, simple FM transmitter. Wow, that is simple. Look at that. This transmitter can be tuned to the FM broadcast band, 2 meters, or other VHF bands by changing C5 and L1. The values given for C5 and L1 will place the frequency somewhere in the FM broadcast band. L1 is 4 turns of 20 gauge enameled wire, air wound, 1/4 inch in diameter, 5 millimeters long, and center tapped. There we go. So there's a coil in there somewhere. Oh, there it is, L1. Yeah, interesting. The microphone is an electric type, and the antenna is 18 inches of any type of wire. Keep all leads as short as possible to minimize stray capacitance. The range of the transmitter is several hundred yards. Wow. Ultrasonics. Ultrasonic switch, ultrasonic bug chaser, ultrasonic pest repeller, mosquito repelling circuit, 40 kilohertz ultrasonic transmitter. All right, this is an ultrasonic switch, ultrasonic bug chaser, low intensity ultrasonic sound waves in the 30 to 45 kilohertz frequency band repel insects and small rodents. The unit is designed to generate a swept square wave from 30 to 45 kilohertz. The LM555 IC is wired as an ultrasonic oscillator driving a piezoelectric speaker of the hi-fi super tweeter type. The output of the oscillator is swept by a 60 Hz signal from the AC input of the bridge rectifier. The LED acts as a pilot. Mosquito repelling circuit, ultrasonic pest repeller, 40 kilohertz ultrasonic transmitter. Video amplifiers, video IF amplifier and low-level video detector circuit, television IF amplifier and detector using an MC1330 and an MC1352, 2-stage wideband amplifier, video IF amplifier and low-level video detector circuit, TV sound IF or FM IF amplifier with quadrature detector, IF amplifier, FET cascode video amplifier, high impedance low capacitor amplifier, JFET bipolar cascode video amplifier, video amplifier, video amplifier. All right. video IF amplifier and low-level video detector circuit. Television IF amplifier and detector using an MC1330 and an MC1352, two-stage wideband amplifier, video IF amplifier and low-level video detector circuit, TV sound IF or FM IF amplifier with quadrature detector, IF amplifier, FET cascode video amplifier, high impedance low capacitance amplifier, JFET bipolar cascode video amplifier, video amplifier, video amplifier. Voltage and current sources and references. Bilateral current source, 0 volt to 20 volt power reference, programmable voltage source, bilateral current source, non-inverting bipolar current source, voltage reference, low voltage adjustable reference supply, voltage reference, low power regulator reference, high stability voltage reference, plus or minus 3 volt reference, plus or minus 5 volt reference, Xenoless precision millivolt source, plus or minus 10 volt reference, precision reference square wave voltage reference, inverting bipolar current source, precision reference micro power 10 volt reference, precision reference low noise buffered reference, constant current sourcing, precision dual tracking voltage references, precision reference bipolar output reference, precision reference 0 volt to 20 volt power reference, precision reference standard cell replacement. Bilateral current source, 0 to 20 volt power reference, programmable voltage source, bilateral current source, low voltage adjustable reference supply, non-inverting bipolar current source, voltage reference, low power regulator reference, high stability voltage reference, Xenoless precision millivolt source, plus or minus 3 volt reference, plus or minus 10 volt reference, plus or minus 5 volt reference, precision reference square wave voltage reference, inverting bipolar current source high speed, precision reference micro power 10 volt reference, precision reference low noise buffered reference, constant current source, precision dual tracking voltage references, precision reference bipolar output reference, precision reference 0 volt to 20 volt power reference, precision reference standard cell replacement. Voltage controlled oscillators. Linear voltage control oscillator. Actually, I'm going to take a break. I'll be back. Alright, voltage controlled oscillators. Linear voltage controlled oscillator, 10 Hz to 10 kHz voltage controlled oscillator, precision voltage controlled oscillator, voltage controlled oscillator, simple voltage controlled oscillator, 3 decades VCO, 2 decade high frequency VCO, voltage controlled oscillator, voltage controlled oscillator. This is a linear voltage controlled oscillator. This is a 10 Hz to 10 kHz voltage controlled oscillator. Precision voltage controlled oscillator, voltage controlled oscillator, simple voltage controlled oscillator, 3 decades VCO, 2 decade high frequency VCO, voltage controlled oscillator, voltage controlled oscillator. Voltage to frequency converters, 10 Hz to 10 kHz voltage frequency converter, voltage to frequency converter, voltage to frequency converter, VF conversion, positive input voltage, ultra precision VF conversion, negative input voltage. 10 Hz to 10 kHz voltage to frequency converter, voltage to frequency converter, voltage to frequency converter, and VF conversion, positive input voltage. Ultra precision VF converter, and VF conversion with negative input voltage. Voltmeters, 3 3/4 digit DVM, 4 decade, plus or minus 0.4 volt, plus or minus 4 volt, plus or minus 40 volt, plus or minus 400 volt, full scale. Automatic nulling DVM, 3.5 digit true RMS AC voltmeter, 3.5 digit DVM common anode display, DVM auto calibrate circuit, FET voltmeter, extended range VU meter, bar mode, high input impedance millivolt meter, wideband AC voltmeter, suppressed zero meter, AC millivolt meter, 4.5 digit LCD DVM, and a sensitive low cost VT VM. All right, this is a DVM. It's a digital voltmeter. Very good. Automatic nulling DVM. Quite sure what that means. 3.5 digit true RMS AC voltmeter. And again, another 3.5 digit DVM. Auto calibrate circuit. Okay. FET voltmeter. Extended range VU meter. High input impedance millivolt meter. Wideband AC voltmeter. Suppressed zero meter. AC millivolt meter. 4.5 digit LCD DVM made out of a handful of integrated circuits. Sensitive low cost VTVM. Waveform and function generators. Low cost adjustable function generator, DAC controlled function generator, high speed waveform generator, programmed function generator, 100 kHz quadrature oscillator, strobe tone burst generator, low cost high frequency generator, tone burst oscillator and decoder, triangle and square wave form generator, 10 kHz oscillator, 50 kHz oscillator, variable audio oscillator, 20 Hz to 20 kHz, gated oscillator, exponential digitally controlled oscillator, function generator, clock source, precision oscillator with 20 nanosecond switching, oscillator with quadrature output, wide range variable oscillator, frequency divider and staircase generator, precision oscillator to switch 100 milliamp loads. Low cost adjustable function generator, DAC controlled function generator, programmed function generator, 100 kHz quadrature oscillator, strobe tone burst generator, low cost high frequency generator, tone burst oscillator and decoder, triangle and square wave form generator, 10 kHz oscillator, 50 kHz oscillator, variable audio oscillator, 20 Hz to 20 kHz. It's all done with an integrated circuit. Gated oscillator, exponential digitally controlled oscillator, function generator, clock source, precision oscillator with 20 nanosecond switching, oscillator with quadrature output, wide range variable oscillator, frequency divider and staircase generator, precision oscillator to switch 10 milliamp loads, zero crossing detectors, zero crossing switch, zero crossing detector, zero crossing detector, zero crossing detector with temperature sensor, zero crossing detector, zero crossing detector. So here's a zero crossing switch, zero crossing detector. When switching loads with the aid of a thyristor, a large amount of RFI, that's radio frequency interference, can be generated unless some form of zero crossing switch is used. The circuit shows a simple single transistor zero crossing switch. R1 and R2 act as a potential divider. The potential at their junction is about 10% of the AC voltage. This voltage level is fed via R3 to the transistor's base. If the voltage at this point is above 0.2, the transistor will conduct, shunting away thyristor gate current to ground. When the line potential is less than about 2 volts, it is possible to trigger the thyristor. The diode D1 is to remove any negative potential that might cause reverse breakdown. Alright, so there's a bunch of zero crossing detectors. And here we are up to sources. This is the sources meticulously catalogued in the back here. And we got all the way through to chapter, what's the last chapter? 98. Holy cow, nearly 100 chapters. And here's the index. Okay. I'll quick flip through that. Wow. There we go. The most comprehensive, up-to-date, and easy-to-use collection of electronic circuits designs available today. So that's the first one done. I'll throw over the Fairball cam. We'll wrap up.
That's a wrap. So wasn't that some fun? This is the first book. There's 7 of these, so we've done one, and we'll do the others over the next couple of months. I guess it'll take us to get through all of those. But that's going to be the new thing. We're going to go through all of them. So that's 1 down, 6 to go. So if you're here, you made it to the end of the video, congratulations. I hope you learned a thing or two. I've been just trying to survey the territory, so I'm trying to get a feel for the expanse or the breadth of the sort of electronics field. So I find that flipping through these things helps me get my bearings. About what's possible with electronics. Of course, this is old technology. This is stuff from the 80s. So all of today's digital stuff, microcontrollers and all that, not covered there yet. But it's all still relevant today. So good to know where we came from. Anyway, look, I hope you've enjoyed this video. Thanks very much for watching, and please remember to click like and subscribe.